everyone. Morning, in-person people and Zoom people. I'm Mark Miller from the Lawrence Berkeley National Laboratory. We'll be starting in 1 minute.
Mark, would you like me to share my slides and follow along with Chris, or will you share the slides to the Zoom eventually?
We are recording. Good question.
Share your screen on Zoom.
Share my screen on Zoom. Yes, thank you. We have excellent IT support here. Zoom, can you see the slides?
Yes.
Okay,
Yes,
and I guess
can
I
you
have
hear
to
us?
minimize this. All right, let's begin. Like I said, my name is Mark Miller from the Biosciences Data Systems Department at Lawrence Berkeley National Laboratory. I'm one of the contributors to the LinkML project, and you will meet many more today, many of whom are listed here on this slide. And excuse me. We have a pretty structured presentation today. It'll be alternating between lecture and exercises. We have a link for the Google Drive from which you can get the slides, and there's a Google Sheet that we'll be using later. There's a link here for the slides themselves. And something we want to emphasize as early on as possible is that to get the most value out of this half day that we'll be spending together is that you should have a GitHub account, and you should have Python 3.9 installed on your computer, and really ideally it should be your default Python interpreter. Chris and I will be taking turns here at the podium. We have some other people here in this room who have experience with developing against LinkML and Python. So please ask as early on as you can if you have any concerns. If you're ready now, if you have Python 3.9 installed, this is one of the very first steps that we'll be running, which is installing Python by downloading it with the curl command and then piping the output of that download process into Python. So if you don't have GitHub, Python 3.9, and if you're uneasy about running this command, please get my attention as soon as I hand it over to Chris. We will be taking breaks, and we have a GitHub repository, github.com linkml/linkml-tutorial that has GitHub branches corresponding to each section we're doing. So if you struggle, and at least you know how to use GitHub, or you get somebody's attention, you'll be able to clone everything up to the step that we're currently working on with a fetch operation and a checkout operation. So the first speaker today is Chris Mungall. He's the leader of the Biosystems Data Sciences group at the Lawrence Berkeley National Laboratory, and is one of the original contributors to the LinkML project. Ready?
All right.
Okay, thank you.
All right. Thanks everyone online, and thanks everyone in person. It's good to see a lot of you again. So just before we get started with the actual hands-on tutorial itself, I'm going to give you a little bit of background on LinkML, why it exists, why we created it. So we're here at ICBO. Obviously, this is a conference for ontologies, and I think we're doing pretty good with ontologies. This slide shows just a section of some ontologies that are part of OBO, the gene ontology, human phenotype ontology, cell ontology, ENVO. These ontologies are being actively used to annotate, in some cases, huge amounts of data, and the ontologies themselves are nicely linked together. If you're, I encourage you to all come to like the OBO tutorial, which is happening tomorrow. You'll hear more about all of this if you don't know about it already. So there's a lot of work to do here, but I think we're doing great with ontologies and systems for building ontologies and systems for integrating ontologies. So this means, we've solved the problem of data interoperation, right? Well, maybe not quite. We've got shared vocabularies for sharing terms between database systems, but many of these database systems and these database formats are using different shapes of data, different database schemas, and these are maybe not quite so compatible. So there's more work ahead of us to do. So, and the problem here isn't necessarily a lack of standards for sharing data. We've got a huge amount of them. Fair sharing here catalogs over 1,800 databases and 1,500 distinct standards, almost all in the biomedical domain. And so, coupled with all of these ontologies, we've got no shortage of kind of systems for being able to standardize data, but we still have a big database interoperation problem. So in theory, if you look at fair sharing, then you can see that these ontologies that I showed earlier are, widely used across different standards. This kind of graph, you can see this is centered around Uberon in the middle, and these are all other ontologies that link to Uberon or databases or standards that we use Uberon. So in theory, we're seeing a lot of use. But in practice, maybe the standards aren't being used quite so widely when you peek beneath the covers. So this is an analysis that was done by some of the fair shake people, where they just looked at the common fund data ecosystem at some data sets and found that there was still a lot of work to do in terms of actually making use of standard anatomical terms within the data. And so this is something we've also observed in the metagenomic realm as well. We did this analysis where we tried to make use of data from the biosample databases from DBJ, NCBI, EBI, and we wanted to do a metagenomic analysis where we looked at correlations between metagenomic communities and different parameters that were captured about samples, such as how deep in the ocean or how deep in the soil the sample was taken from. And it turns out, these samples were not, these standards were not very widely adhered to. This is actual data that you can get from the biosample database, where all people had to do was fill in a field with a number and a space and then a standard unit after it. And people just kind of throw in all kinds of junk into this. So needless to say, this makes meta-analysis very, very, very difficult. And then, we've got frameworks like JSON Schema, which are great for validating data in JSON format, but there's not really a standard way to incorporate ontologies into JSON Schema. This is from the JSON Schema discussion board, where there was questions about how to use long codes within JSON Schema, and the upshot is there's not really any one standard way to do this. So in theory, we're at an ontology conference where I think many of us are familiar with the semantic web. So we think, okay, well, the semantic web is here to save us. It's been around, 20 years. It gives us, a lot of the building blocks that we need for data standardization. We've got URIs to be able to identify things. We've got basic constructs like properties, classes, triples for making statements. And then layered on top of this, we've got RDF schema, OWL for ontologies, rule languages, shape languages, and so on. But, we're maybe not quite seeing the adoption that we might like. And parallel to the development of the semantic web, there's also been, active work, within the ISO community, coming up with standards like ISO 11179, which gives a standard way of aligning data dictionaries with existing standards. This is commonly used within the NIH data ecosystem, common data elements, CDEs, and so on. That all kind of adopt this ISO 1179 standard. But, what we really see as a kind of like end result of this is different silos where different groups prefer different technologies that don't necessarily speak very well to one another. So we've got, semantic web enthusiasts maybe overrepresented at this conference who love kind of technologies like RDF. They're maybe not quite so widely loved when you go to more data science oriented communities. People prefer big flat tabular data they can do machine learning over. We're going to be hearing more about machine learning tomorrow as well. And of course, a lot of biologists and clinicians just love using kind of like Excel and flat tabular data as well. So what I think we need here is some kind of like universal connector box that can speak all of these different frameworks. And we want this to be simple as well. We want it to be easy to adopt. almost that, my cat could do this, or maybe not quite, but make it, let's make it as easy as possible. So that's the goal with LinkML, to be the simple universal connector box for data. So what it is exactly is, you can think of this as being two parts. There's the LinkML standard itself, which is kind of like a meta standard for being able to structure your data. And it gives you kind of elements such as schemas and classes and slots, which are fields within schemas. But more importantly, it gives you a set of tools as well. And we'll be covering some of these today, but not all of them. So I'll just try and give you a flavor of the full tool landscape. But these tools include validators for checking data, data converters, ways of entering data, and ways of being able to infer data models from existing messy data. So the overall landscape looks a bit like this. We're not going to cover all of this today. And most people who use LinkML don't necessarily use all of this. They pick one path through the landscape. But the basic idea on the left here is that we want to democratize the editing of these standards and schemas, make it easy for biocurators, data scientists, as well as data modelers. You'll author your schema using typically a simple YAML format. And that YAML conforms to the LinkML standard. Then that YAML can be converted into other forms as well. And it can be converted into more semantic webby kind of like frameworks like OWL, shape languages like Shex and Shackle, JSON-LD contexts. But it can also convert to things that are maybe part of a more traditional development stack as well. So JSON schema, Python data classes, SQL create table statements, TSVs, and so on. So you can pick the right tools to get the job that you need done. So I'll work through just a sort of simple scenario. Imagine we're part of a data collection center, Omics are us, and you're a data wrangler at the data collection center. So as a data wrangler, you want to be able to design a data submission standard that's easy for people submitting omics data together with associated data about, metadata about the sample, so that experimentalists and can easily submit data to the DCC, and the DCC can, more importantly, integrate it with all the other data being submitted and data that's coming in, from other sources as well, and make it maximally fair for community reuse. So the idea here is that you can, as the chief data wrangler, maybe you can create your LinkML schema, defining your data dictionary. Looks something like this. We'll go into this in more detail, but just to give you a flavor of the anatomy of a LinkML schema, there's a bit of metadata up at the top, just about your data model itself. Some namespaces that allow you to map to standard RDF and OBO vocabularies. Dependencies allowing you to create a modular schema where you reuse parts of other schemas. And then the actual data model itself, where you describe your entities of interest here. You're describing a person that might have names, that knows other persons, and so on. And you've got a variety of options for authoring these schemas. You can author them directly in YAML using your favorite text editor. We recommend using IDEs. We actually have kind of like ways of kind of like boosting standard IDEs like PyCharm and VS Code, such that you have some kind of like support for autocomplete and so on. Turns out, if any of you use GitHub Copilot, it's actually amazingly good at helping you author schemas as well as code and sample data file. It's kind of scarily. I'm not sure there's not like an army of people actually typing some of this thing for you. But anyway, and we'll hear about some productivity tools like the LinkML linter later on. So that's one option for maybe slightly more technical people. You don't need coding skills, but it helps to know YAML syntax. We also have a simpler option that we'll hear about today as well, where you can create your data dictionaries just as simple Excel files or Google Sheets, and you can list all of the different kind of like elements of your schema there. So that can be quite useful if you have like maybe a large number of curators who aren't technical, and you're just capturing like kind of 100, 200 different variables, about people or about samples or observations and so on. You don't necessarily want them all editing a YAML file for that. And we won't hear about this today, but just to kind of give you a flavor as well, we've got a growing number of semi-automated approaches for building schemas, taking as input, things that are already maybe described in JSON schema, maybe existing messy data in TSVs, and it will do things like semi-automate building the schema using lookup services like BioPortal to kind of help annotate those as well. And so there's some existing tools to help people who need to submit data. So again, imagine we're the head of data wrangling at this DCC. We want to make it easy for people to submit data to us. What maybe people have done traditionally in the past is, just kind of manually created a spreadsheet with the kind of like the fields that people need to fill in. There's some nice productivity tools here where LinkML can give you a standard kind of Excel template that people can fill things in. And then, it can go through the standard LinkML validation stack after that as well. There's a nice new tool developed by Damien Dooley and friends at Simon Fraser University called Data Harmonizer. Damien's actually next door in the food ontology section today, but you can kind of find him if you're in person at this conference. Hear more about this. We won't be going into this today, but this is a really nice tool, and I just want to advertise it here. It's integrated with LinkML, so you can just automatically build essentially a data entry UI that's kind of fully web-based. It's got all the drop-down forms for your kind of ontologies and so on. And this just makes it, we're using this heavily in one of our projects, and this makes it very easy for non-technical people to enter data conformant with the schema. And then there's different tools for validating that data as well. So we can do things like if we've got a very traditional JSON-based data infrastructure. So one of our projects, we have this, we're using kind of MongoDB and so on, and we want to validate all the JSON that comes in via JSON schema. And maybe you have people submitting JSON data as well, maybe more data scientists, more technical people. So you can do things like generate a JSON schema, validate against that. Question from.
You have a background when to use LinkML, because in some settings, I can imagine I can set up the system from scratch, and I'd be maybe inclined to use LinkML, but in the system, it might not be there, or it might be underneath.
I'll say maybe a little bit now, and I think that's a good thing for sort of discussion after we've kind of sponged in some of the tutorial. So the question was when is a good time to use LinkML? So I'd say it's good to use it as early as possible, and it's good to use it from the outset. But we've a lot of experience with kind of like coming into existing projects that maybe have some existing kind of architecture and technologies and so on. Then it's kind of a case-by-case basis, but I think it's still good to bring it in as soon as possible. And we have tools for, retroactively going from, if you've already got a SQL database, if you've already got, kind of JSON schema and so on, to be able to kind of like generate the LinkML from that, and then kind of essentially drop that into existing architecture. So it's very much designed to parasitize off, it's the ultimate data parasite framework. It's designed to, work with existing systems rather than replace them. So.
Okay, so I could use this also if I have a Red Cat system set up somewhere.
In theory, I am not a Red Cat expert. We've got a few people in the room who I think are familiar with it, but I think that is definitely something that could be possible. All right, so just to give you a flavor of some other tools as well, it gives you the ability to generate searchable static websites thanks to the beauty of GitHub Pages and material for make docs. So really without just using the existing GitHub Actions infrastructure, it's possible to just kind of essentially press a button and have a website up and available with little kind of like figures and descriptions of all of your different schema elements and so on. And particularly for this audience, what we're interested in, I think, is being able to integrate existing ontologies into some of these standards. So this can be done in two ways. You can think of using ontologies to describe the elements of your data dictionary. If you want to describe everything from like, your person name field in your schema through to your tissue sampling site, your symptoms and so on. So you can, do this kind of like alignment with your data dictionary, with your database fields and so on, annotate them using ontologies, using LinkML. But you can also use LinkML to standardize the value sets that you're using. So maybe I'm building something for entering patient data. I want to be able to say that I want to use this branch of the human phenotype ontology to fill in this field here. To describe my brain sample, I want to use this branch of Uberon over here. Maybe I've just got a very small value set, like a couple of terms, describing vital status, alive or dead. Maybe I want to just have a static value set taken from Pato and so on. So I'll kind of go through briefly how this can be done. So you'll see every LinkML file has this header section where you can define, just like in many RDF formats, a set of prefixes that are handy to use to kind of like contract full URIs. And then you can do things like describe the elements of your schema. Here we're using schema.org, but if you like, you could use the information artifact ontology or your favorite OBO ontology here. Describe your classes like persons, your slots like family name and so on. This kind of thing you can find in schema.org. But you can also describe your value sets as well. So maybe you've got some kind of like chemical data entry system, and you're describing different kinds of nanostructures. Maybe you want to pull just a nanostructure hierarchy from Kebi and just say this is my my value set here, nanotube, nanoparticle, and so on. Each of these are optionally mapped to a Kebi ID, and this essentially gives you data interoperation hooks. So you can use just enums the same way that you would use them in JSON schema or in Python or in a relational database, but behind the scenes, it's kind of like it's integrated. And then a new feature is this ability to do what we call a dynamic enumeration. So you might want to be able to say that this field in my schema can take any subtype of neuron from the cell ontology. So there's a little syntax, a little kind of like graph path type syntax. So you can say this field here is a neuron type, and neuron type is anything that's reachable from the node CL540, which represents neuron in the cell ontology, or any transitive subclass thereof. Okay, so I don't really have time to go into some of the different groups that are using LinkML here, but it's fairly new, but we've got a lot of adoption across different projects. And one thing I really want to emphasize is just the different ways that this is being used in some of these projects. So yeah, I'm part of the NCAT's Biomedical Data Translator Consortium. We're using this essentially to define a common standard called BioLink for knowledge graphs. So this is for being able to describe rich, interlinked biomedical knowledge. But we're also using this maybe just for big flat data dictionaries as well as part of the MCSS Genomic Standards Consortium. And we're also using it in things like the Alliance for Genome Resources to describe something that's more like a traditional kind of a relational database type schema, where we've got kind of like interlinked entities such as genes and genes, pathways, diseases, and so on. So so we're definitely interested in adoption, and we adopt ourselves as well. So one thing that's maybe a little bit kind of meta at first is LinkML is itself described in LinkML. We eat our own dog food. We have a site for the LinkML standard that is generated using the website generation methodology from LinkML. So you can look up all of the different elements of the LinkML schema itself on the LinkML site. And of course, each of these has its own standard URI and so on. So we strive to be a very open, helpful, and inclusive community. It's fairly active. There's a lot happening on our GitHub. We have our code of conduct here, and we're really striving to kind of like bring as many people together, and we're really welcoming of all kinds of contributions to the framework, whether it's kind of like helping with documentation or the code or the actual kind of like standard itself. So here's a link to our issue tracker. This is a good way of getting in touch with us as well. Just recently introduced like a feature voting system as well. We recently got funding as well, just a supplement on an existing grant. It's funding to do things like this, workshops and tutorials to harden the infrastructure, to do more integration with kind of like frameworks like Google Big Data to do kind of validation at scale, and also to come up with a kind of like a standardized core research subject data model that can be adopted by different projects like different data commons and so on. All right, so I think that takes us to just to 9:30 on the dot. Okay, so right, I guess we can take maybe a couple of questions now, and then but then I suggest a lot of this if this will become hopefully clearer as we actually get into some of the hands-on exercises that will follow. So I see it. Mm-hmm.
Does the LinkML has to use any ontology terms?
The question is, does LinkML have to use any ontology terms? And no, it's all entirely optional. Now, the linter, may complain at you if you've not kind of like done a good job of kind of like annotating your schema. But if you want to, you can just kind of create a schema where you say, I'm describing kind of like a person, and I'm using all of these fields to describe a person, and I'm making up my own kind of like enumerations. You can do that kind of quite happily, just as you would with like JSON schema or something like that. But everything is designed to encourage you to use ontologies as far as possible to make your data interoperable.
This is helpful, like there is this new data management and sharing policy.
Yeah. Mm-hmm. Yeah. Mm-hmm. Yeah, I think it could be useful for that. I think Rob, you were first, and then Mm-hmm.
Okay,
Mhm.
Thank you. For somebody like me who's very new to LinkML, you maybe outline the basic differences to semantic web standards like using RDF as
Yeah. Mm-hmm. So the question was why, compare it quickly to our existing RDF standards. So I think the RDF standard it makes most sense to compare it to is shape languages like Schex and Shackle. So there's a big debate in the kind of, not really a debate, but there's a lot of confusion, I think, in the semantic web world right now, where a lot of people have used OWL to describe things that are more like schemas than like ontologies. We've had great success in using OWL for things like the gene ontology and for human phenotype ontology that are like 10,000 different terms. That's a great use of OWL. But for describing, a schema, OWL is not great because it's an open world framework. And what you really need to validate data is a kind of closed world framework where you can say, there must be a value populated for this field here. OWL will tell you that yes, there is a value for that field. You've just not not specified it. So this is where shape languages like Schex and Shackle come in. And so there's a lot of parallels, and we actually have kind of like ways of going from LinkML to Schex or Shackle. And I'd say the main differentiating factor is you can use this with semantic web standards, or you can just use it as part of a more traditional, data science kind of infrastructure as well. With something like Shackle, it's great if your entire universe is already RDF and everything's already in a triple store. That's not really kind of how it is in the world, a lot of times today. So I see, LinkML as a kind of like a bridging standard there that can bring a lot of the semantic web technology to people who are using non-semantic web tools.
Yeah, and then can you easily change any data frame by the LinkML to any other format like RDF or the
Yes, yeah, we won't have a lot of time to go into that today, but we'll show briefly how to go from something like JSON into RDF. So yeah, that's definitely one of the main use cases. All right, so maybe two more questions, then we'll go. So I think you're first in the back.
LinkML helping me to serialize the beginnings of my ontology based on the format I choose.
So you can use it to do that. We're not going to cover that today, but I'd say if that's not really the kind of primary use case today. And I'd say maybe if you're around, come back. Hopefully, I'd recommend you join the OBO tutorial tomorrow, and that will tell you all about how to get started with an ontology. So.
Is there a parallel between R2RML and ML?
R2ML is a mapping language. So it's a way of mapping from like kind of, I think from relational databases to RDF and from like JSON to RDF. And there's like YARML, which is a simplified form of that as well. So I'd say that, no, they're not quite the same thing. That's very much a narrow use case of kind of converting data rather than describing the data. There is some overlaps, but I think that gets into slightly more nuanced territory there. Mhm.
I'm just wondering how I could incorporate the portion of LinkML in the R to RML mapping.
Yes.
You sort of this thing going on the manual.
Yeah. No, I'd be interested in talking more with you about that later on. Mhm. Okay. I think with that, we're going to go into the next session here. The next person presenting is going to be Sujai Patil, also at Berkeley Lab. And so Sujai is responsible for a lot of the lovely documentation generation and that we saw earlier. So Sujai is going to, first of all, walk us through and getting set up with a LinkML project. And this is all hands-on. So you can follow along. If you are online on Zoom, we have helpers on Zoom. So just put questions in chat. I think there's been a lot of that happening already. And if you're in the room and while Sujai is talking, just kind of put up your hand and someone can run over and kind of like help you if you're having any issues there. So with that, I'll hand it over to you, Sujai. Are you there?
Yes, I'm here. Can you all hear me? Hello?
I hear you.
Okay, perfect.
First,
Certainly, we'll need to make him a host for the Zoom section. Sorry, I didn't do that before.
yes. First of all, he will need to share. But first of all, can you hear us, Sujai?
Yeah, I can hear you.
Stacey's talking, but maybe you're. Do we have the IT person here?
I probably muted myself. I'm going to unmute myself. Maybe there'll be some feedback and we'll have to deal with that.
Can you hear us
Sujai,
now?
can you speak now?
Yes. Can you hear me, Mark?
We can hear you.
Yes.
Okay, excellent.
We have to share your screen. Give us a moment.
Yes.
Oh, no, I just heard maybe the IT guy.
Oh, sorry.
Yeah, I'm just in the hall with.
We're sorry.
Yeah.
Okay.
Everyone can see my screen, right? Hello?
We can see it on Zoom. Yeah, we can see it on Zoom. Can the in-person audience see the screen?
Yes, we can. Do you want to go into slideshow mode?
Yes, excellent. Yes. Okay.
I will get rid of it. 2 seconds.
Okay, so I'll get started. So thank you, Chris, for that wonderful introduction on LinkML. Okay, so now that we have all the necessary software installed, the software that Mark was alluding to in an earlier slide, where basically he was talking about Python 3.9 and higher, a GitHub account, and poetry, we can begin creating our first LinkML project. And in this section of the presentation or tutorial, we'll be setting up a LinkML project, and we're going to learn how to use this one tool called LinkML Project Cookie Cutter to get set up with a skeleton LinkML project. And before getting into the steps for setting up a LinkML project, let's note a few points about LinkML schema repositories. All LinkML schema repositories, including the one that you are about to make as part of this tutorial, all follow the best open source repository design, development, and maintenance practices. Now, to belabor a few points about what I mean when I say best practices, the repositories that you create will all contain licensing files. And you can choose from among the MIT license, the Apache license, and various other academic open source licensing options while you're initializing your repository. You can also automatically initialize your schema and its associated source files as a Git repository and push all of these files to GitHub if you wish to do so. Also, there are a number of GitHub Actions workflows, which are basically just GitHub automation workflows that take care of a number of repetitive tasks for you. And the simplest example of this task would be running your project test suite every time there's a new commit that's pushed to a branch, or every time a new pull request is made, let's say. And the tooling that's built into the schema repos also allows you to generate web documentation to better describe your schema, and also allows non-data modelers to explore your schema using a web interface. Now, LinkML schema repos also facilitate the validation of real-world instance data against your hand-authored LinkML schemas. And finally, the repos also ship with an automatic update system called Craft, so that the projects that you are continuously developing do not get out of date as LinkML evolves. Now, I'll give you an example of how this is useful. Like, there are standard documentation templates that can be found in the upstream LinkML repository that controls how the layout and the content on the documentation pages is structured. And there are regular updates to these templates. An update to these templates in the cookie cutter can be picked up by Craft with a simple Craft update command. And all of these benefits come bundled in a template that can be customized on initialization. And the template is called LinkML project cookie cutter. Now, a good starting point if you're authoring a LinkML schema from scratch is getting set up with a bare bones LinkML project using this cookie cutter template that I've been talking about called LinkML project cookie cutter. Now, a cookie cutter is essentially just, if you're confused by what a cookie cutter means, a cookie cutter is essentially just a project template that allows you to customize and create projects. Now, there are three main steps that we will follow as part of this cookie cutter setup. So we're going to do all of this hands-on now. The first step will be creating a Poetry virtual environment for all of your LinkML projects. So I'm assuming folks already have Poetry installed on their machines. Step two will be creating a bare bones LinkML project from its cookie cutter template. And step three will be optionally deploying this newly created LinkML project that you created just now as part of this tutorial to GitHub. Okay. So cookie cutter step. So the step one as part of the tutorial is the creation of this one folder. Okay. So let's get into the hands-on part of it. So I'm gonna sort of exit this window and I'm going to open up my terminal here. So I'm assuming everyone can see my terminal. Let me know if you want me to increase the font on this. And there's a number of commands that I have in here that I'm going to run. Now, okay, so I'll just talk a little bit about this first. Yeah, so the first step that we're going to, the first set of commands that we're going to run before getting set up with the LinkML project is the creation of this one folder called LinkML projects, which will basically store all of your LinkML related projects moving forward. Now, in order to do that, you're going to run the first two commands that you see on screen, mkdir LinkML projects, and then you're going to cd into that folder. So, what this? Okay, so let's do both of those commands first. So feel free to, yeah, just open up your terminal. If you're running on a Windows machine, just open up either CMD or just open up the WSL Bash on Windows terminal, and then just type in,
maybe just make the font a little bit bigger.
Oh, a little bit bigger. Yes. Let me know when it's sufficient.
Is that good for people in here?
Is this good?
That's good.
Okay, excellent. So I'm going to navigate to whatever folder where you normally store your projects. And so for me, it's desktop. So I've already navigated onto desktop on my machine. And I'm going to execute these first two commands, which is mkdir LinkML-projects and cd into LinkML-_projects. So let me know when folks are through with that step. And so these are like fairly simple tasks. So you should be able to square these up pretty quickly. While folks are doing that, I'll just talk about a little bit about what a virtual environment is, a Python virtual environment is. A virtual environment is basically just a lightweight, isolated Python environment that you can create and discard when you don't need it anymore. And the purpose of creating an isolated environment is so that any external packages that you install won't conflict with your global site packages. And there are a number of virtual environment creation tools that I've listed on here. Sorry, that I've listed on here, like pipenv, virtualenv, vn, and this vn was something that comes bundled with Python versions 3.8 onwards natively. However, we recommend using Poetry, since that is the tool that is used by the LinkML core repository and its associated libraries as well. And yes, so I'm assuming folks already have Poetry installed on their machines. And the way in which you would verify if Poetry is installed on your machine is by running poetry -- version. And here it tells me that I'm using Poetry version 1.1.12. So I'd like folks to try running Poetry -- version to make sure that they already have Poetry installed on their machines. Once they've made sure that they have it installed on the machines, the next step you're going to run is this poetry init command. Now, what the init command does is it's basically going to help you create something known as a pyproject.toml file. And it's going to do this interactively by prompting you to provide like basic information about your Python package or library. And so we're going to do a few things here. So I'm going to accept. So what you're going to do is you're going to want to accept, accept the defaults that the prompt gives you. So just accept all the defaults. Compatible Python versions 3.9 and higher. Would you like to define your main dependencies interactively? Just say no. Would you like to define your development dependencies interactively? Say no again. Do you confirm generation? Yes. Okay, excellent. So just let me know if folks are seeing all of these prompts. And sorry, I haven't been able to monitor the Zoom chat, so I hope the Zoom participants are doing just fine. But basically, what you're going to get at the end of this step is this one file created within your LinkML projects folder called pyproject.toml, and you can view the contents of this pyproject.toml, and it should have this tool.poetry section, tool poetry dependency section, dev dependencies, and build system. So let me know if folks have gotten to this step in the process.
Let me just do a quick check in the room. Anyone
Yes.
having any issues they need help with? Or?
Do we need to change this file somehow? I didn't catch that.
No, you don't need to change it. This is just
Okay.
to verify this. Yeah. I think we're good in the room. We've got one issue. A Windows machine. If there's any Windows experts here, we can do some help. But but other than that, I think we're good in the room here.
Okay, excellent. Just make sure that you have the pyproject.toml file by simply lsing within your LinkML projects folder. So you should see this pyproject.toml file. And once you see that file, you know that you've successfully executed this poetry init step. Okay, so there's positive feedback from everyone in the room. So I'm going to move on to the next step, and that is running this command that you see in this box here, which is poetry add craft. So poetry add craft. So okay, so I'll just execute this step first, and then I'll tell you while this is going through, I'll tell you a little bit about what craft is. So yes, so poetry init, the init command created a pyproject.toml file for you. And the next step was to install craft into your poetry virtual environment. Now, Cookie Cutter in combination with craft are the go-to tools for us when it comes to templating. Now, Cookie Cutter is the templating tool, while craft gives us the possibility for keeping the generated projects up to date with the template from which they were generated from. Now, the command that you need to run in order to install craft into your virtual environment is basically poetry add craft, which I just ran, which you saw me run just now. So the command that I ran was poetry add craft. So once you created your poetry virtual environment, the next command to run is, once you created your pyproject.toml file, the next step was to run poetry add craft. And some things that went on in the background of poetry add craft were the creation of this virtual environment called LinkML projects. And the reason why it's a virtual environment is because that's what poetry uses to create and manage virtual environments. And the virtual environment can be found here. I'll show you all of that. And the virtual environment itself is called LinkML projects. So you're going to do an ls minus la here. And what you're going to see is this .ven folder. That's how you know a virtual environment has been created within the LinkML projects repository. And the step that you run should also, the poetry add craft step should also create a poetry-based lock file for you. So you should see when you do an ls minus la or ls minus a, you should see a .ven folder, a poetry.lock file, and a pyproject.toml file. So that's basically the checkpoint for your output at the end of poetry add craft. So let me know.
Just there, Sajai. So
I don't have the .vm.
I think don't worry if you don't have the .vnv. It's set up the virtual environment somewhere else by default. So I think that's just maybe a preference setting. I know a poetry expert online can just confirm that, but I think if you don't see that .vnv, don't worry about it. I'm pretty sure everything will work.
Oh yeah. Yeah.
What was the command that you ran just before?
The last command should
yes,
bring that
the
up.
last, yes, the last, sorry, bringing it up. That is poetry add craft. This was the last command that I ran, and this is what the output looks like. Last command, poetry add craft, and it should start logging things like creating virtual and LinkML projects and so forth.
Are we all good in the room? Okay. Thumbs up. Over
Excellent.
Here.
Yeah, I just run this poetry env list in case you want to find out where your virtual env environment was created. Like Chris said, it might not necessarily be in this .env location. Okay, excellent. So moving on, next slide. Okay, the next slide.
Can I start? Sorry, can I just interrupt you really quick, Sujai?
Oh, yes.
Some folks in the chat have asked, what do I do if I can't get poetry running? And that's totally okay. You can use the virtual environment of your choice to do this step. And if that's still not working, you want to follow along, please do look at the slides. There is a link in there for checking out the repository that we're going to be working on. So you can just work in your regular Python environment, check out the code and follow along that way.
Yeah, and if you have Python already installed on your machine, you can create a virtual environment by running this very simple step using Python's Ven module, and then you can start doing all of the next steps. But yes, okay, I'll move on to the next step since I'm a little short on time. So the next step is basically the most important. The most crucial step in the cookie cutter process, where you're basically fetching the LinkML project cookie cutter template, and creating a project from this using craft. And so at this stage, basically, you'll be prompted to answer a few questions about your schema, and that information will basically be used to initialize a LinkML project. And when you're answering all of these questions, these prompts, be sure to use names that make sense to you. So some fields that you'll be asked to enter values for will be this name field, basically the name of your schema. And for this, it's recommended that you use kebab case with no spaces while naming your project. For example, you can use linkml-tutorial for the purposes of this demonstration. Then GitHub.org. If you have an organization that you are part of under which you want to create the repo, then use that. Else, simply use your GitHub username, basically. Whatever username you have when you've created a GitHub account, just use that name. Description, ideally a brief one-line description of your project. Full name, basically your full name. Email, your email address. Main schema class. So this is the class that will be used to generate an example schema which you can edit. And for the purposes of this demonstration, we'll be using the class name person. Then there's this other prompt that you'll be asked to answer called create Python project. and answer yes to this to set up the repository as a Python package that you can deploy to PyP. And please answer no to the use schema sheets prompt and accept the defaults for all the other prompts to follow, like Google Sheet ID, Google Sheet tabs, and so forth. And one point to remember is that all of these parameters can be reconfigured at any time by tweaking certain source files in the project folder. So what I'm going to do now is go back into my terminal and execute this command that you see up on the screen. Poetry run craft create, and feel free to copy over the link from the slide. Sorry, just 1 second. Copy over the link from the slides. Poetry run craft create and the link. So that's what you want to do, and hit enter.
Does anyone need the link to the slides?
Oh, yes.
So copy and paste from there if you need it.
So template, and I put the template link in. Oh yeah,
So
thanks,
could you-
Sierra. Sorry.
Could you bring up briefly again the URL for the slide deck?
Oh
The
yes,
bit.ly
sorry. I
And
apologize.
the bit.ly link. I think it's on like on the first slide, but it's
Oh,
bit.ly
yeah.
slash
Oh, I'm sorry.
LinkML, case sensitive, capital L, capital ML, dash 2022. So down here at the bottom. So if you're having, there are a few different kind of like URLs that you'll need to copy during this, but everything you can navigate to from within this slide deck. So again, bit.ly, LinkML, 2022, case sensitive.
If anyone here is a Windows user and is making good progress, we have a Windows user who's having trouble getting the Python executable on their default system path. So let me know.
Which Python install is it? Is it Anaconda?
It looks like it. No, it looks like it's from like Python.org.
Okay. If it's installed as Anaconda, then you can bring up the Anaconda prompt. Ask that user, it should let them do that. That's what I was doing. But then running poetry commands in my government equipment, Symantec quarantine poetry. So I think the poetry demo from the poetry site I found last night. I think poetry init is what I didn't try last night, which triggered that.
Okay, I'm gonna not note that down. Thank you.
Perhaps you already said it, but can I get a brief explanation to why? Take off frame. Yeah. I think lots of us have trouble with poetry, like maybe this installing it because 0.8 for people and it's right.
Oh.
So I think that would be helpful. Yeah.
CJ
So,
just
so
Sorry,
while
is it?
wait
Sorry.
for people to get set up here, I'll just kind
Okay.
of
Oh,
there's
yes,
a very good question, which was kind of like, why do we have to go through this business of using poetry? What's poetry? Why are you using it? So really, if you're already experienced with Python, you can bypass the poetry part here. Really, we just need a way of getting ourselves bootstrapped. Now, unfortunately, the Python ecosystem is kind of quite complex for getting things set up if you're not already an expert. There's a kind of XKCD cartoon about this, about all the different versions of Python on your system. So we needed one way of just getting everyone onto kind of like roughly the same kind of ecosystem so that we could help support them. And so we already use Python poetry within LinkML as our default for getting projects set up. It is a nice way of being able to kind of provide a standard virtual environment for Python and a very nice standard way of being able to specify your dependencies. And I think it's working for most of us here, but we're having a few issues with.
Does the poetry do more than just install dependencies? Because I mean, you can do that with a requirement text file and then just install that. But here it seems like it's asking you for more information or configuring more metadata about the repository.
Yeah.
What it is.
Yeah, so for people who are already experienced with kind of like Python, the question is, why not just go with a simple requirements.txt? So poetry gives you a bit more. It allows you, it's got a very standard way of separating your development dependencies from your main ones. It's got a very nice standardized way of specifying which versions of things you need. It incorporates all the metadata you need for a project into one file. And it also gives you something called a poetry lock file that allows you to be completely in step with other developers in terms of exactly which versions of everything you have installed, which can make debugging things, you know, a lot simpler. But if you're already a Python developer and you love just using bare requirements.txt, or you love using pipenv, you know, you can still use everything that way, but you know, we're just trying to kind of streamline everything and get everyone doing things the same way for today.
I'm not a Python guru, but is poetry analogous to Maven or Linigan?
Yes, exactly. Maven, Linigan, you know, the other one is NPM if you're coming from a Node or JavaScript universe.
Question, is Python 3.9 strictly required for this tutorial? Or is 3.8 also okay?
I believe 3.8 should work, but we've done the run through many times with 3.9, but I don't think you should have any problems with 3.8.
I'm getting an error when I do make install after the prompt create.
Okay, yeah, let's take a look. Mark.
Okay. No, this is an error.
Yeah, I did that error too. Don't worry about it. You can just.
Okay, I was hoping you could say that.
Yeah, so this is a case where running poetry init and then poetry install gives you a misleading error message. If you did poetry init, if you did poetry init and poetry add prompt, then you should be able to proceed to that steps.
Okay. Thank you. That's not how it goes.
Should we align with the breaks here?
I talked to Sierra, we had a planned break at 10:50, but this is when the food services arrived. Sujai, I'm sorry, I didn't discuss it with you. Can you hear me from back here?
Yeah, I can hear you, Mark.
Sujai?
Yes, I can hear you. Yeah, I can hear you.
Oh, good. How far are you through your slides? And is now an okay time for people to take a coffee break?
Oh, it's okay. I should be done in like 5 minutes, but if you think
Great.
Why don't we push through just now then? And
Yes.
We'll have our break, the sync with the coffee breaks here, and then we can also help people during coffee break as well. All right.
Okay,
So do you want to-
excellent. So I'll just talk through this really quickly. So like I described in the slides before, please enter all of these values when creating your schema. So I've already done it. So the first prompt that you're going to see is project_name. Please enter LinkML-tutorial for that. GitHub org, please enter your GitHub account name. Project description, enter anything you want. I've just entered a simple my tutorial schema here. Your full name, the name of the schema developer, the full your email, of course, and then you're gonna be prompted to select a license. Please enter 1, 2, 3, or 4 based on whatever license you want to pick for your GitHub your repository. Accept the default for Google Analytics G tag, and for this main schema class, please enter person. I mean, even if you don't, it's going to pick person by default, because whatever you see in this square brackets here is the default value for this particular option. So that's going to happen. And then for this select create Python classes prompt, please enter 1 because you want it to be a Python package. And for select use schema sheets, please select option 1, no. And then accept the defaults for all the other options to follow. And once you've done all of that, you should see this one very nice little log message that says project creation complete, and it should give you the next steps that you should run as part of this process. So let me know when folks in the room have reached this step.
And while we wait, Sujai or Sierra, can you take a look at the Zoom chat? Chris and I haven't been monitoring it real closely.
Yes, of course.
Thank you.
Yeah, both Tim and Sujai and I, all of us are monitoring the Zoom chat. So if you do have a question that you don't want to interrupt the whole meeting for, you can always put it in the Zoom chat and we'll do our best to help you debug on the fly here. I just want to point out too that if poetry is messing you up or a virtual environment is messing you up, don't worry. If Cruft is messing you up, you can always check out that main tutorial from our repository again. And just follow along with us there. You don't even need to start a virtual environment. You'll be able to do the rest of the tutorial just using that repository. So yeah, the rest stop. There we go. Thank you, Sujai. So here's, if you can't get that working, there is an alternative. It's this LinkML tutorial repository. You can just check it out and navigate to this branch. Maybe we could just leave this slide up during the break and people can post in the chat if they need us.
Excellent idea. Yeah, so when the folks in the room are ready, just let me know and I can talk through this next slide really quickly, like a minute or two. Yeah, so the output you're gonna get is has to look like this. You have to see this project creation complete log message. And it should give you directions on the next steps post that. So when Chris and Mark, either of them give me a thumbs up, I'll just start talking through the next slides after. So I'll leave my terminal window open so you know what the output is supposed to look like.
So Sujai, we're sort of like drifting into the coffee break here. So why don't we just kind of take us to the rest stop?
Yes, of course. Okay, excellent. So here's the rest stop. And if you haven't reached haven't gotten output from all of the previous steps, what you're going to want to do is, simply clone the repository, this LinkML project repository, this LinkML tutorial repository, and then check out onto this one branch called Step 0 Basic Project Creation branch. And you can find the branch linked in this section 1 portion of the slides. So feel free to just click on the link if you want to navigate to the GitHub branch. So just clicking on this will take you to this branch. You're going to want to have the contents of this branch on your local machine. So you should have this LinkML tutorial folder, and and you should do git checkout step 0 basic project documentation. Okay, excellent. So this is what you're going to want to see. If you're this is if you're using Visual Studio Code. I'll just leave this slide open here. So so once folks get back from the coffee break, Sierra can take over from there. So let me know when folks are back. And Sierra, if you want to switch and if you want to leave the slides open, that's fine too. I can stop sharing.
That'd be great. Yeah, thank you.
Excellent. Okay, stop sharing. So, on to you, Sierra.
Okay, get started again. Can you just, if you're still having problems just getting Poetry set up, can you just kind of put up your hand in the room and maybe raise your, say in Zoom as well. So I know we've got a few people at the front here. Anyone else having issues just with Poetry? Okay, so we'll continue to kind of try and help you, but we're going to kind of like move on with the rest of the tutorial now. So Sujai, do you want to kind of like just kind of finish up here? And
oh, sure.
Okay, good. We can hear you. Mm-hmm.
Okay, you can hear me. Oh, sorry. Sorry. I think I might have closed the. Could you share it? I can just talk through it really quickly. A couple of slides that I missed maybe. Okay, so once you're done with the creation of the LinkML tutorial folder within your LinkML projects folder, the next thing that you're going to excellent. The next thing that you're going to do is to so as the documentation says, do cd LinkML tutorial and make setup, and in the if you execute make setup, it does 4 main things. Firstly, it installs the dependencies that are listed in your LinkML projects by project.toml file. Then next thing it does is it generates all project files that you're seeing on the log screen right now. Basically, it creates all LinkML artifacts that can be created with the LinkML suite of generators. For example, the OWL artifact will be created by the OWL generator. The JSON schema artifact will be created by the JSON schema generator, and so forth. And then third point is the automatic generation of markdown documentation from the schema, which is eventually transformed into HTML documentation and rendered on a web interface. And finally, the initialization of a schema project folder as a Git repository with the eventual motivation that the repository will be pushed to a Git-based repository hosting site such as GitHub. So so if you do an ls -l in this terminal here, so you'll see all the artifacts that I talked about created here. Firstly, just take a look at the pyproject.toml file. You'll see all the necessary dependencies installed in there. And then if you go back here, there's the project folder that should have gotten created here. If you just take a look at what the contents of the project folder, you'll see everything, all the artifacts that are that the LinkML suite of generators have created. Like for example, the JSON schema folder will have the JSON schema artifact. The OWL folder will have the OWL artifact, and so forth. And then the schema has also been initialized as a Git repository. If you do an ls -la Sierra, you'll see a .git folder in there, with meaning that the folder has been initialized as a Git folder, as a Git folder. Yes. And then finally, the last slide is basically pushing whatever folder that you just created to GitHub. So there's a link there on the first slide, the github.com/new. So you're going to want to click on that link. It's going to take you to a GitHub page, and there you're going to type in your repository name, which is basically LinkML-tutorial, kebab case LinkML tutorial. Feel free to name it whatever you want. Feel free to fill in a description as well. And feel free to select whatever public or private, whatever you want to select, and don't check any of these options, like leave add a README file unchecked, because the cookie cutter is going to add a README file for you. And also don't do anything to this add.gitignore file, because cookie cutter is going to add something for you. And if you recall, when going through the cookie cutter setup, you also picked a license for your repository, so you don't need to pick a license here. Simply hit the big green create repository button, and you'll see the second section, basically push an existing repository from the command line. Just execute all of these commands in succession. So git remote add origin, whatever, git branch, switch to the main branch, and then simply push your local git repository contents to GitHub. So yeah. So see what Sierra basically did here was to push whatever we created as part of LinkML.
So maybe just kind of pause for a moment there. Let's just kind of quickly check where people are at. So the sequence of commands that Sujai just typed, it's just copying and pasting from that GitHub site. But maybe we need just to pause for a moment just to make sure we're at the same place here. Can we just, anyone need some help kind of getting to that step?
Question, the last step, last command, the push command didn't work out. I had an error on that one. Remote rejection to the person access token.
Did you demonstrate it under your own username?
Yes. This is where it is. The username, and it's also
I'm sorry, I mean,
so as the failed English rep
The best thing there is just delete that and if repository GitHub and try it again. Yeah. I think we've got a few backgrounds for people as well. After doing
I've not been monitoring the Zoom chat. How are you? How are the folks attending virtually getting on with the steps so far? Great. Yeah. We're having a few, just a couple of network and GitHub issues here, but why don't you go on just now, Sujai, and then we'll maybe when we start your sessions here, we can also mention the backup again of just kind of following up with creating your own repo. So yeah, carry on, Sujai.
Oh yeah, that was the last slide as part of my section, basically pushing whatever LinkML tutorial schema that you created on your local machine to GitHub. So if you've sort of finished, if you're through with that step, then great. If not, there's the slide that Sierra has brought up on the screen, and you can always just find the LinkML tutorial folder and then check out into the specific branch that's pointed on that slide, basically step 0, basic project creation branch.
All right, we'll do it. Why don't you bring up your slides, Sierra, but just talk us all through that. Okay, so a few folks, if you're having issues either with Poetry or with Git and Git push, we're also going to mention a backup here where you can just basically clone the ready-made repo and you can still follow along with that. So if you are having problems, just follow on to the next bit and it will all be made clear here. So Sierra, do you want to?
Yeah, sure. That's great.
that?
So let's go through how you get to the backup, the rest stop, because I think it's important. Even I'm having a little trouble here monitoring the chat. So let's go through.
Hold on, we can't.
Am I muted again? Can you hear me?
We can hear you on the Zoom chat. On the sorry, on the.
I'm not sure if you were speaking, Sierra, but we can hear you here.
Yeah, I think I'm muted again there.
There we go.
Oh, can you hear me now?
Yes.
Okay, great. All right. So yeah, let's walk through the rest stop because it's super helpful and it'll just get us all on the same page to start the next more fun spot where we can actually model some things using LinkML. So I'm in my LinkML projects folder. It's the first step we did. We just made that projects folder and I'm going to go ahead and clone this repository that we've set up to get along in the rest stop. So I'm just going to say git clone this link. It's a repository under the LinkML organization called LinkML tutorial, and I'm going to call it toot. And we're going to clone it. And then I can go over into my new repository and check out a branch here. Step 0, basic project setup. I believe that's what it's called. It's not, of course. Let's go back to our slides. Basic project creation. There we go. So now I'm on the branch where if you were successful along the way here, you would have gotten this branch set up locally via the cookie cutter and via your Poetry environment. If you haven't, it's totally okay. Like we can just switch to this branch and you'll be at the same stage as I am talking through this. Does that make sense? You can go slower through it too if it didn't. And I'm just going to switch back over into my tutorial branch that I have set up going here, and we're going to keep going. Yeah, and so those commands here for checking out and getting that branch are just right here in this orange section. You can kind of just copy and paste once you have a location of that tutorial repository. From your browser, you can just kind of copy and paste.
Can you just bring up the git clone command as well?
Yeah.
So, are those of you who are having trouble with the part before, are you following this part or do you need help? with checking out the repo. Can you just stick that into slide 50, Sierra?
Mhm.
Okay, I think we're ready to go on.
Okay, great. Okay, so now we're going to talk a little bit about actually using the modeling language that LinkML provides to make a single source of truth for your
Sorry,
project.
I don't know what's going on, but you keep getting auto muted. Let me figure this out. Okay, I'm sorry, could you start again, Sierra?
Yeah, sure. Okay, so now we're going to start talking about how to use the LinkML modeling language itself to write and document a model. And that's going to be the single source of truth for our project. And so what we wanted to do was find something that was fairly familiar to all of us on the call without knowing much about your background or what you've done already with modeling. And so we figured we're all people here. We can try to describe some of the characteristics of ourselves to this group. Of course, that's very fraught with lots and lots of discussions, and it'd be fun to have them here, but let's just come with the base level that we're not going to get it right from an ontology point of view at the first here, but it is a good domain to talk about things in a situation where a lot of people know a lot of different things about a lot of different things. So if I was going to describe a person, I might start with its sort of really basic characteristics. I might talk about the person's age, maybe their birth date, depending on what I needed from that person, whether or not they were alive or dead. These seem like sort of basic attributes. I might also look at their administrative characteristics, maybe I need to know about their primary email address or what lab they're in or what organization they're a part of. If I really want to know about the person, I might go into more detail about the pets they have in their life. We all have pets, we all love them, they're part of our family. Let's try to model them as well. And then, of course, on the biomedical side, maybe we want to talk about the exposures that they have in their life, or whether or not they have a certain disease or a medical event. These are all very good attributes of a person that we can model together. And so in this section, we're really going to try to look at the LinkML modeling language specifically and talk about how we describe groups of things that all have the same attributes, classes, and also those attributes themselves, and how we can really constrain them down so that the data entry into our system passes this single source of truth or this model. We're also going to talk about how LinkML provides a nice hierarchy framework, so you can have your groups of things, your classes inherit from one another, and you can also have your slots or your columns in a table. These are all sort of analogous ways of describing parts of the model, can be hierarchically arranged as well. We're also going to go into detail about how you can map your schema to a well-defined schema in another location or domain. And we're going to go through a little bit of validation and testing, talk about in a bit more detail the enumerations that Chris mentioned in the beginning, and then give you a little run through or a show and tell of the LinkML convert command, which is a handy thing that you can use to convert test data in a YAML format into JSON format or into RDF. And just again, each part of this tutorial comes with a little link here. So if we're in the modeling components section of our tutorial, you can always click here, double click that, right? Just assuming you have the slides already, and you're going to get to a 404 arrow, because of course you are, it's a live demo, but I'll show you as we go along that those do work, and we'll get to the place we are in the schema. So the first thing I want you to do, it's a very easy step. I want you to navigate to this LinkML tutorial YAML that we've gotten to from our cookie cutter or from cloning the repo. And if you are in the top level of your repository, LinkML tutorial is what I called mine. If I do an ls, I can see I have a source. Did I go mute again?
Your audio, Sarah.
Of course. Can you hear me now?
Sorry, Sujai, can we just check? Is your audio working?
Hi, can you hear me, Chris?
Can you
Yes,
hear me?
we can hear you.
You can't hear me at all?
Yes, we can hear you now.
Okay.
Okay, sorry about that.
Sorry. Okay, so if you look in your original, I'm not sure where I cut off, but if you look in what the directory that we just created, you should have some directories underneath it, like source. And under source, there is a LinkML tutorial folder, and under that, there is a schema folder, and under that is our LinkML tutorial YAML. And the first thing I'm going to ask you to do is delete a bunch of stuff from it. So you can use your favorite editor. If you're on a Mac or a Linux box, Nano comes by default. You can kind of see in that you'll have this big file. If you click Nano and you can open it up, I am actually going to use PyCharm. So let me stop my share and reshare a couple more screens here. I like PyCharm because it's an integrative development environment. Chris sort of went over why it's nice at the beginning of this. I can also use GitHub Copilot and helps me draft LinkML really quickly. So I'm going to use PyCharm. If you're a Java developer, the similar integrative development environment is IntelliJ. They're both JetBrains projects, etc. So the first thing I want you to do is navigate to that LinkML tutorial YAML file and delete a bunch of stuff. In fact, I want you to delete everything under the keyword classes, just like that. Because although LinkML tries to come and give you a nice example, we're going to walk through it ourselves here in the tutorial. So I just want to start from a fresh slate. So if you can go ahead and just delete everything under classes, we'll get on with the modeling. And while you're doing that, I'll talk through some of the boilerplate that comes when you have a schema generated from the template in LinkML. Chris mentioned this at the beginning of our talk here, but we have some top level header information. This is one of the most important parts. You always want to give your schema a unique identifier. It's a good modeling practice when you're making any kind of model, but in particular, LinkML asks you to do that as well. It gives you a nice URL that you can uniquely define your schema with. You also have some more metadata. You can add a name, a title, a description. The license gets pulled in from that cookie cutter template. I chose MIT, just the default. You could also choose an OpenCC license. That's probably better. We'll probably change that going forward. And then it gives you a nice link to the auto documentation that we're going to generate towards the end of this tutorial. So that's kind of like the header information. And did I go mute again?
No,
Sorry,
you sound fine. I just wanted to check with the audience. We suggested two different editors, PyCharm and Nano. And in PyCharm, you just selected a bunch of lines and hit delete. But people who is anybody using Nano?
Yeah.
Okay, so in Nano, you go to each line you want to delete and you just do Control-K, 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 Control-K. Is everybody up to that point so far? Okay. Thanks, Sierra. Continue.
Okay, great. And I'm not watching the chat, so I think Tim is our helpful Zoom monitor and he's watching the chat for us. Okay, and please interrupt me at any time. I know I'm going really fast, so I don't mind being interrupted at all. The next step here that you're going to get for free is a section of prefixes. LinkML is really committed to having uniquely identified data, even for its own schema on the web. So it's going to want you to, if you refer to something by a short form URL, it's going to want you to have the prefixes associated that are mapped to their full form URLs here in the top of the header. And go ahead. You're also going to get a couple of defaults. You're going to get a default prefix for the modeling elements in our model. That's the LinkML tutorial. That's our default prefix for an identifier that refers to any classes we make in our model. And you're going to get a default range. And the default range is just a way to say, if I forget to tell you what the type of this attribute is, just assume I meant string and put it in there for me. Just a little helper function. But we're going to actually try to define our ranges going forward very specifically. And then the final thing that I want to mention is that LinkML allows you to import schemas from other locations, which is really helpful. If something has been developed over the course of many years in LinkML, you want to be able to just take that. You want to be able to parasitize that from someone else. You can just import it here in this section. And in fact, we do that ourselves by importing the types that LinkML provides. And these are very familiar software development types like integer, string, Boolean. Those kind of types come from LinkML itself. And in fact, you can make custom types if you'd like them. So LinkML also has a custom type that's named URI or query. And that's a union of a short form URI and a long form URI. And we'll actually constrain that for you. So if I put in Sierra : 123, LinkML knows that's a query, especially if I've added it to the range, and it's going to verify that I have that syntax in my type. Okay, so that's just some background on the header. We've deleted everything under classes and we are ready to go. So I've kind of been talking through this slide already, but I just want to mention it. You know, a lot of us come from different backgrounds with regards to modeling, right? So in my background, I spent a lot of time in relational databases and also in graph databases. So I've worked a lot with SQL and JSON schema. And, you know, if I'm in an SQL serialization, I might talk about tables and columns. If I'm in a JSON schema serialization, I might talk about objects and properties. In LinkML, I'm going to talk about classes and slots. So a class is to a table, as a slot is to a column, etc. And the thing that I really like about LinkML is that, you know, yes, you're going to have to learn this new syntax for LinkML, but what I can do is test very quickly my current understanding of how LinkML is working with just a push button command that serializes my LinkML model into the format that I'm more familiar with when I'm learning. So I can, you know, say make gen project or whatever the command is that I'll give you in these slides, don't worry, and it'll take my LinkML model and shove it into SQL so I can see if what my mental map is of what I'm trying to model is equivalent to the LinkML schema. And really, that's hard to do in other frameworks. If I was going to try to say, well, I'm going to learn how to model Hibernate object relational mappings, I'd have to set up a lot of infrastructure to be able to test my vision of what I want my model to be all the way down into the Java class, for example. So that's one of my favorite parts of LinkML. The other favorite part I have is that, you know, you can really talk about models as a single source of truth between teams. So I can have a software development team that speaks very clearly in Python and a subject matter expertise team that speaks very clearly in biology. And we can sit at the boundary of those two teams and really educate people on both sides of the aisle about our respective domains in a single language. So let's just keep that in mind. If you forget what it is, you can always refer back to that slide if you're from a different modeling paradigm. So let's finally get into it. We're back to looking at a person, right? And the first thing we need to do is create these big bins that we're going to hold all the attributes that individuals of our bins share in common. So what I mean is when I'm describing a bin in LinkML, I'm really just describing a class. In SQL, I'm describing a table. So the first thing I'm going to do, and we can follow along if you'd like, is to create a person class. And let's just say I'm very interested in households and I wanted to model how a household looks. So the other important part of my household are children, and a very important part of the household to them are our pets. So let's just avoid the children for a minute because they come with their own baggage. And let's just try pets or animals maybe, because we don't know exactly what kind of pets we have. So those are my two bins that I want. And that's it. I've defined a class in LinkML. It's just a little indented bit of text right underneath the class's keyword. And the other thing that I need to do is describe how my persons and animals interact with each other, and also what defines them as a unique bin or group of things. And so this is where I need to start describing the attributes of my classes that disambiguate them from one another. And you can see Google Copilot is trying very hard to write the schema for me. I disagree with its boilerplate, but not incomplete. But it's doing a lot of good work here. So let's just ignore it for a minute and add some attributes that I think my person will have. I think, it'll have a name. It might have an age in years, right? It might have a birth date. A person might have a primary email address. Thank you, GitHub Copilot. It has a secondary email, but let's ignore it. We'll go back to our sheet here. What else do we have? Right, so we have, there's another person in the waiting room. We have some vital statistics. So vital status. Person might have a vital status. True. What else? Let's see. Yeah, so I think that's pretty good. In terms of my animal, maybe my person will also have some pets. We'll see. I'm sure it'll have some pets. And then for my animal, I might want to describe my animal in the following ways. I might want to list its breed, maybe, or its species, maybe its color. It also has a name, but I've sort of defined name already here in my slots. Maybe it has a weight if I'm worried about keeping track of that for the vet. I might have a weight in milligrams. Let's see, that might be it. So those are the kinds of attributes I see my people and my animals having in my model. And what I want to do now, the reason I'm defining these separately is that if you can remember, I think people and animals might have names, right? So I'm going to define in my class that the person has a name, and also down here in my animals class, I'm going to define that the animal has a name. Right. And the nice part about LinkML is that I can define those names separately and be able to constrain them outside of a class. I'll also show you how to constrain a slot within a class if you want to make it more specific for one of your classes than another. But I think probably that's straightforward. Again, stop me if I'm going too fast. I think we've probably forgot something very important here, and that is all of our classes should have an identifier, right? A unique way of identifying one particular person from another. So I'm going to go back here and add identifier to my animals and my persons. And yeah, so I think that's a good start. Let's see what else. Let's add.
Yeah. I think you need a slots object on your animals.
Oh, yeah, thank you very much. Right, like that. Okay. And let's see, a person has an age in years, right? And so does an animal. It might have a birth date. So does a person. You can kind of get the picture here where they have a lot in common, but maybe not everything. So a person might have an email address. I don't think my kids have given our pets email addresses yet, but I wouldn't be surprised. But let's see. So primary email is here. And I don't think my pet does. The pet might have some slots that the person doesn't have too. It has a breed and a species, although a person could have a species, of course. They all have species. It also has a color and a weight in milligrams. If you tried to take my weight in milligrams, that would be exercise in very long numbers. So I'm going to leave that out of my person for now. Okay, so now I have two classes that have some slots in them. And I don't have very much defined about what those slots are. So now if I had some test data that came in and was deficient in ID and name, and it only had age and birth date, that would be perfectly acceptable for my schema, because I haven't put any constraints around what kinds of values I require for my classes, nor have I put any constraints around what those values could be. So if age and years came in as the color magenta, I would accept it because there's no requirements on my schema to make it anything other than a string. Remember, we've defaulted our range to string. So now it's probably time for us to talk about how to constrain down our schema a little bit more in terms of defining our slots. And the most important one, I think, is an identifier for our classes, so we can have a short handle to refer to each individual of our class by. And LinkML provides some nice ways of constraining down these really important properties like identifiers. We are gonna, GitHub Copilot is giving me lots of examples. Good job, GitHub Copilot. So we're gonna constrain it down in a few different ways. One, we're gonna say that an identifier has to be single valued. I'm gonna set the LinkML property of multi-valued to false. I only want a single identifier for each of my individuals. I want the identifier to be required, right? Because I don't want to have a person come in without an identifier. How will I ever tell that that person is different than another? And I want that identifier to be a string. Sure, that makes sense for me right now. We can expand on that later. I talked a little bit about this at the beginning. We can set that to the special LinkML type of URI or query so that we have a real good format for identifiers. So now any of my people data that come in with an identifier of a social security number will fail because that's not a query in my world. And then I can, even put some examples of how I want the identifier to look here. And I'm going to add one more field that is another keyword in LinkML, which is identifier. And that actually takes care of this required for me. Identifier is like a primary key of a table, or a required and unique property in a JSON schema. I'm not actually sure you can say unique in JSON schema, but you can call it required. So that's going to take care of the required for us for ID. And for name, I'm going to add some defaults here too. I do want name to be a string. Description, it's the name of my object. Age in years, I want the range of that to be an integer. Birth date, I want it to be constrained to a date. I don't want some random things in there. As you remember from Chris's slide with just get people to add in some numbers with their units, people can definitely add whatever they want. Here, I don't know, email is a weird one. I know it has to have an @ symbol in it. I know it has to have a domain and an identifier, but at the moment in our tutorial, we don't have any way to know whether or not I can constrain it that way. So I'm just going to call it a string for now. Vital status, again, string, that's all I have for myself. Pets. Now here's an interesting one. Pets I know are not going to be people. So what I can do in LinkML is actually set a range of animal to my pets slot, and then LinkML will constrain these pets to be objects that have the required fields of our animal class, right? So that's kind of a handy way of saying, I know pets are only going to be animals. I'm not going to have a person pet, right? And let's see, range for the breed. Right now I'm going to be a string, although I know in the back of my mind, because there's a talk coming up at this conference, that there is a breed ontology. So, you know, maybe I'll put a thing there's to do, make this constrained by the VBO, the verbit breed ontology, and then species, the same thing. I'm actually going to do something here. I'm going to say that it has to be an NCBI taxon class, but I can't do that yet because we don't have it in our model. So I'm just going to say it's got to be a query, and I'll constrain by the NCBI taxon ontology. Right? Color, string again, weight in milligrams. I'm going to have that be an integer. Okay, so now I have a lot of more definition in my model, even though a lot of these are strings. At least the person coming in to look at the model can see that they're strings and know what kind of data would be acceptable for us. And at the same time, I'm going to show you that when you make those templates or check out our repository, it's going to come with some test data already put into it. So if you click over to source data examples, I'll do that on the command line here, just a second. All right, so in the top level of our directory in source data examples, there is some example data already. And if I use less or nano, I can use nano. That's easy enough to look at some of that data. It's going to show you that we have an identifier that is a query, we have a name, we have a primary email address, and an age in years. And this is in YAML format. This is just some test data that comes with the project to begin with. And you can also look at our animal one. And it has nothing right now because we haven't added any animal data to that. Okay, so let's see where we are. So we have required, we have range, we have our description. One thing I really want to mention is that right now my schema makes a lot of sense to me because I am in my own head and I'm talking about persons and animals, and I'm trying to model this like relationship between household members. But anyone else coming in and not hearing me talk for the last 10 minutes, 20 minutes about this won't have any idea what I'm talking about. And so what I really need to do is go through all my slots and add some descriptions and really try to be a better citizen here and give people a clue about what I'm doing. I don't have time to do that all right now, but if you check out the next version of the template in the repository, you'll see that I've went through and added a bunch of descriptions to that as well. Okay, so let me move a little bit faster. Now I know if I look at the person and animals classes here that we've done a lot of repetition. We've replicated ID, name, age and years, birth date in both our person and animals classes. In terms of maintenance of our model, if we get a really big model, that's going to be just like 2 places to make mistakes. Let's just have 1 place to make mistakes, for example. And also, I want a way to constrain a slot like something like household members, where I want that slot to be either persons or animals. So we looked around already at how you can constrain by a certain class. I could say household members has to be people, but I don't really have a way yet in this tutorial on how to make that persons or animal, right? Like there is no syntax for that. So what we need to do really is create a grouping class for our persons and our animals to help ourselves out. So I'm going to just call this named thing. because I don't know what it is other than a named thing. And it's going to have some slots, and those slots are going to be an identifier. I'm just going to pull out the ones that we have duplicated in our classes. Here, you could make this anything you wanted, right? Of course, it's just another class, but I'm going to try to pull out the ones that are duplicated. And I'm going to add a special note here in person to, just like an ontology, make this inherit its properties from my grouping class. So I'm going to say a person is a named thing, and I'm going to say a animal is a named thing. And then what I can do is I can get rid of all this duplication, right? I can say persons have primary emails, and maybe they have a vital status. I think I forgot that one. Alive or dead. But animals also have those, and I can get rid of them. And now the things that disambiguate my two classes are really the things that make them unique and give them a reason for being, other than just these boilerplate fields that I want to have in all my objects. And if I come down here to this household members, I now have a unique way to say that household members must be constrained by either a person or an animal. And that's sort of how hierarchies work. I'm going to add two more helpful classes for the rest of our demo. This is going to allow us to submit more than one person or animal to our test suite, right? Because we want to test more than one of these guys and entities. So just bear with me a second. So I'm going to add a person collection, which is a named thing. That means that anything in the named thing, actually, I'm not going to make it a named thing. I want the person collection to actually have persons. And in my animal collection, I really want it to have an animal. I want it to be all the slots of animals. So I'm going to add a couple of more slots here that I'll describe in just a minute. So I have these two grouping classes that are going to hold collections of my person.
Did you catch that, Sarah? I was wondering, did you mean to do that? The animal collection is an animal?
Oh, no, thank you.
It's a collection of animals, right? How can it be an animal?
My bad, my bad, my bad. I'm trying to go too quickly.
And Sierra, keep going. I think we'll trim down linting and documentation a little bit because this is so fundamental to the tutorial.
Are we already over time? Okay, I'll try to go quickly here. So person and animal collection, they're both named things. They have these slots that contain collections. Here's where I was talking about collections of people or animals. So our entities collection will have a collection of persons, and our animals class, our animals slot will have a collection of animals, right? And so what that allows us to do is come back to our person example data, and I'm gonna have this entry slot, right? That's our collection slot that says it's got to be constrained by people. And I'm gonna move this into a collection. And I'm going to be able to add another person here, right? And he's going to be named Fred Blogs. And here's Fred Blogs here, right? And he's going to be 34. So now I have two people that can test out my model. And what I've noticed already by looking at my test data, which is a good way to exercise your model, is that I don't have any clue of whether or not Fred or Fubar are alive or dead. And that's a vital part of my schema. So I know something already just by looking at the test data is not right here. So I have vital status in person, that's right. But why don't I have it in my test data? Oh, it's because I haven't required vital status. So I'm going to set the required property true here. And that means that when we get to validation, I'm going to really need to know if Fred and Fu are alive or dead. And vital status. Well, we'll just give him, he needs to be alive too. Okay, so we've gotten through those, and some important parts about these collection objects, you can just kind of go along with me here, is that they have.
Sarah, we had a question about, does it make sense for them to inherit named thing? And maybe, I think maybe that's, maybe that is a mistake. We don't actually need.
You don't need to, nope. further on in the tutorial, we might get into, making name thing even more broad and making a middle class here between person and animal. But you don't need to. They can be their own tops. They can be roots, actually. This is a good thing. Thanks for pointing that out. We're going to make these the top level classes so that we can submit data to them. So we're going to add this special thing called tree root. And we're going to say that their collections underneath them are going to be inlined, which means I'm going to be able to submit data that is a collection underneath these collections, right? So I'm going to inline them. I'm going to see the definitions of these subclasses inlined. So those are our boilerplates. Again, if I'm typing too quickly, which I know I am, let's go to this URL and let's just make sure we can get there. Right, so now we're on step 3 in our tutorial here, modeling step 3, hierarchies, and that LinkML, that little URL is going to take you right to this already filled out schema. And if you want, you can just, copy the entire thing and replace all of my typos that I've made because it's a live demo with that I've already figured out, right? So now we have our named thing, our person, our animal, our person collection. We might even have an animal collection, right? And we have our household members that we talked about and our entries, which is inlined as a list, and it has the range of person. So that's where we are in the tutorial. We're on hierarchies, and now I'm going to move on to mappings and URIs. Does that make sense to everybody, or shall we pause here for a minute?
Did everyone get the URL to go to the branch in GitHub to get this version of the file? So,
I have a general question.
Yeah.
Multiple ranges.
So there's a general question, can you have multiple ranges? So it depends what you mean by multiple ranges. So
Well, in OWL, I'm not going to use the word plenty, but in OWL2, if I have an object property with an annotation property to it, would that be allowable as a range?
I thought I was following, I didn't quite follow the OWL example. I was hoping you were going to lead me into talking about unions, but I didn't quite get the object property annotation property example. Sorry. Yeah. Okay.
This sounds so. These ranges, if in OWL, many of these look more like a concrete kind of domain XSD, integer.
Yes. So the ranges, are either a kind of scalar type. So this is so there's a type system that Sierra showed with built-in types like string and so on that are mapped to XSD types, or the range can be a class that you define yourself that is not a scalar but a kind of complex object like a person or an animal and so on.
LinkML does not distinguish between data properties and object properties. So there's a question whether can you have a property that has both sometimes scalar and sometimes.
Yes, so there's a special kind of range called any. So you can make something neutral. You can make a slot that is neutral and say this can take kind of strings, or it can take objects, or it can take integers. That might have some consequences if you do want to use the resulting properties with OWL, where you do have to make a commitment one way or the other. But for most purposes, yes, it is possible to be flexible and have very general kind of ranges. But that's typically not necessary, and we do generally recommend that you kind of commit to what your fields, your slots represent. Another question?
Yes, I didn't catch what tree root actually meant.
So the question was about tree roots, Sarah. Do you want to just go back to your schema and maybe just talk just a little? Because I think there was a few questions about collections in general and what we're doing with those. So.
Okay, yeah. So what I'm really trying to do.
I'm sorry. I don't know why your audio keeps going off here, but.
Yeah. So can you hear me now?
Try again.
Okay. Can you hear me now? Nope. Still not there.
No.
Okay.
Can you speak up?
Yes, can you hear me?
Can you hear me?
Yes, and we can hear you now, Sarah. I don't know why that keeps happening.
Wow, very strange.
Thank you, Sujai. So what I'm really doing here is trying to, we can have these little test schemas that have nothing in them but one piece of data. But in the real world, as a data wrangler, you're going to be getting all sorts of different files, right? Enormous files. And we want to be able to give, one of the nice features of LinkML is that you could say, generate a JSON schema out of your LinkML. And that JSON schema can be put up for someone to say, please make your data conform to this JSON schema. I can write parsers from it, etc. And what I want people to do is be able to, the use case that I have for LinkML is that I want people to submit to that JSON schema and have it be validated before it even gets to me, so that I have a clean set of data. And what these grouping classes do, they're not necessarily anything somebody would type in their model directly, but they're just groups of, they're just saying, I'm going to make a group of these kinds of objects, these kinds of classes in my test data. And what TreeRoot does is says, this is an entry point to see more about my classes that I'm going to add. So it's a group of persons in this case, and I'm going to tag that in LinkML so that later on in a validation step, I can say, here's my schema person, or here's my schema LinkML tutorial.yaml. Here's my test data persons, or person 001 as I have it listed here on my screen. And what I want you to do, LinkML, is target the class person collection and validate my incoming data according to the person collection class. And that's going to be a collection of entries, and that collection of entries is a collection of people. And in fact, that collection of entries in my incoming data is going to be inlined as a list. So it's going to actually look like a list of objects here. Does that make more sense, or does anyone else want to try to answer that in a different way?
So TreeRoot basically says, if you think of it in terms of JSON schema, this is the root of the document. So it's, if I'm sending you a JSON document, and I don't want to just send it as a bare list, but I want to kind of like nest things under this collection object. So TreeRoot essentially defines the root of the data tree.
But in this case, you also have animals, right? And the animals wouldn't be under that root.
Yeah. So another way to model this is you might just have a collection object that is a kind of everything collection, and under that you would have, here's my list of persons, here's my list of animals. So yeah, that's a good catch.
It doesn't get a hiccup if you do it like that, right?
It might get a hiccup if you try and communicate both persons and animals in the same JSON document in this case. So that's
Yes.
a good catch. You're paying attention.
It actually will, yeah. So that's sort of why I did it,
Okay,
is because if I try to do a collection with named three,
Okay,
I am so sorry. I don't know what I'm doing wrong.
I'm
but
sorry, we're not hearing you, Sierra.
Can you hear me, Chris?
Can hear you, Sujai? I don't know what this works, but it does. Now we can hear you, Sierra. So
chalk it up to wonderful pandemic zooming. Thank you very much. Okay, so yeah, you're exactly right. If I try to make a collection here with an entry component that is named thing, then just because of my model and the purpose of this demo, it's going to expect that my named things have these 4 slots, and it really needs to, I really want to be submitting data that is to the person or to the animal. So I'm going to make person and animal specific collections. Another thing I forgot here is that I want to make named thing abstract. Oh, I already have it. Never mind. I copied and pasted my schema from my tutorial. I want named thing to be abstract. I don't actually want anyone to submit me any data that's called named thing. I want them to be more specific, but I do want to allow for range constraints that cover both persons and animals. Okay, so now maybe a fun one for this group is that we're going to move on to how do I relate my person to the concept of person that has been talked about in the greater world forever, right? So I am definitely not the first person to talk about what a person is. In fact, I know for sure that schema.org, for one, has talked about persons. So I can say right here in this modeling component from LinkML, I can say that my person definition is exactly the same as the person definition from schema.org. Another LinkML model I work on is BioLink, and I know that my definition of person comes directly from BioLink, so I can make that an exact match. I might also have a Wikidata definition of person, I'm going to make that exactly the same. So when somebody's coming into my model, number one, if you're just coming into it manually, you can go and look at those definitions and see how I'm considering my person to be. If I'm saying it's exactly the same as schema.org, I can actually go to the definition maintained at a separate place and read the definition for my model, right? The other thing I can do is act on these exact mappings programmatically, right? I can create SSSOM mapping files with these mappings in them. So the effort of curation here is not lost, right? We're going to use those in doing inference, etc. LinkML has other kinds of mappings as well. You know, I can have a narrow mapping, and maybe the easiest way to see that is with our animal. One of the things I like to do when I'm writing a schema is go consult the ontology lookup service or bioportal to see what other ontologies say about the thing I'm trying to model. So in this case, an animal, I just entered that into the ontology lookup service, and I'm going to see what I get back here. This one looks very similar. It's a living organism that has cell walls and requires oxygen. These definitely seem like descriptions of what I mean by my pet. Let's not get into the case of roles here. Let's just go with it. So I'm going to say that it's exactly the same as that NCIT definition. And I'm going to scroll down. I might add all of these as well. I get to this food one, and it's kind of an interesting case. Like, what did they actually mean by animal in the food ontology? And so I'm going to click on it, and I'm going to go look and kind of look at how it's related to other parts of its class. And I see that really they're talking about animals as a food product. And, you know, I think in all honesty, some people do raise pets as food, right? You could raise a lamb to make your dinner tonight, or a guinea pig, or whatever you want. But it is kind of a narrower definition of an animal than I'm actually talking about when I'm trying to describe my household as an American living in, you know, Eugene, Oregon. So I'm going to actually put food on as a more narrow definition of animal than what I mean. So you can kind of get the idea here. The LinkML supports all the different SCOS mappings that you would find in ontology, exact, related, close mappings. And it's a really handy way. Oh, go ahead.
You
Sorry.
dropped out a second there, Sierra, but this may be a time to take a question anyway. So
Is this just mapping for terms of like matching definitions? Or then when you're mapping to schema person, are you also able to bring in slots or properties from those other schemas?
no, so just by mapping to schema.org.person, you don't bring in all of the different slots from schema.org, but it does give you a hook point from which you can use tools that then say align my schema with schema.org, or suggest to me fields that schema.org has that I don't have. And you know, so it gives you that integration point from which you can use then automated tooling to do this. And one of the key things is it also gives you a point from which to semi-automate exchange of data as well, because you're using the same URI for the concepts. And in fact, if you were to use LinkML convert to make RDF from that, it does actually use the schema.org as the OWL class for your data in that case.
I may not have fully followed up. So are you, with this, are you able to say, well, for person, I want to use a person as defined in this outside schema, and I want to pull that in?
Yeah, so I think you still have to kind of like pull in what fields you want from schema.org. You could do something like, and you know, we're not going to have time today, but there's an import mechanism. So you can basically take the LinkML version of schema.org, import it, and reuse classes directly. That's one use case. The use case here is more mapping, so it's a less of a commitment to using schema.org. It's more just we're reusing the same concept in general. But yeah, and in theory, if you're using kind of exact mappings, or you're defining it as the class URI, then you're at least committing to having the same conceptual model, even if maybe you decide to include diff fields that they don't, and so on. All right, okay, I think we can carry on, but maybe we should pick up some speed a bit, and maybe we can go on to kind of like enumerations quickly, and then do some of the other sections as a demo. Does that sound good?
Perfect. Yep.
And
So
I think we need you to kind of bring Sierra's.
yeah, Sujai, hi. Hello.
Sujai.
Hi. Oh, sorry. Can you hear me?
Okay.
We're a team. Okay. So to get up to speed with where we are in our tutorial, go ahead and navigate to that enumerations branch, and let's just grab, since we're behind, let's grab where we would end up if we were all the way through the enumerations model, and I'll just talk through it a little bit instead of trying to write it out here for you. Okay, so jumping ahead, we've defined all of our classes, right? We've defined animal, person, named thing, we've added mappings. There are some rule syntaxes we won't go into today, but you can read about it on the tutorial as well. And now we're into constraining our slots even further with some enumerations. So I know as a person that's going to model people that there are only 3 in my definition of vital status, 3 values that I want people to add to my person to tell whether or not they're alive or dead, or I guess I don't know. And so the way I'm going to do that is I'm going to create an enumeration of permissible values. I'm going to say that this particular object, person status, is going to represent the collection of possible values alive, dead, and unknown. And in fact, I go back up here to my person class for my slot for vital status, and instead of making that a string as we did before, I'm going to actually constrain it by that person status enumeration. So it's just a handy way to add a controlled vocabulary to your schema. The other nice thing about LinkML enumerations that Chris went into a little bit is that if I know that there's an external ontology that I want my class to be constrained by or my slot to be constrained by, I can actually make a dynamic enumeration. And that dynamic enumeration can say, you know, my source ontology for my breed of my pet is going to be the VBO, and I'm going to use the query or short form of that bioregistry VBO of that prefix. I'm going to say that the source of that enumeration, where it starts from, is going to be a particular query. In this case, I took the highest level of the VBO.
I'm sorry, I don't know if you're cutting out on Zoom as well, but you cut out again. So
yeah.
Okay.
I'm sorry.
Okay.
All right.
So we can constrain the breed. Can everyone hear me? I hope so.
Yes.
By the ontology, right? And we can constrain it at using the top level of the ontology, the first term in the top of that ontology, the top of the hierarchy. We can even constrain it down further in the ontology. If I know that I have a controlled vocabulary of just one branch of the gene ontology, for example, if I just want my slot to be constrained by cellular components, I can start the top of this enumeration at the cellular component identifier, and then any child of that, defined here by the relationships types LinkML construct, is going to be included in my enumeration. And right now we are still working on code to make the enumerations materialize, but even just putting this in your schema for people to look at is going to really help them make a better data submission or a data constraint for you to go with. So I think that's all I'm going to say about enumerations. Again, you can go to this link right here in the tutorial and copy and paste the schema so far. And I think we'll just skip over LinkML convert for now and get on with the linter. We can also skip this break because I think we already took it. Does that sound great, Chris? Or would you like me to talk about?
I think that sounds great, but could you just maybe do the validate slide just to kind of
Sure.
emphasize, you know, how it works. We don't necessarily have to kind of go through the demo of that.
Okay, so I'm just going to, as an example here, let me go to the top of our repository, and there is a built-in function called LinkML validate. It's going to take my instance data, my test data, and validate it against a particular class.
I'm sorry, we lost you, Sujai.
Are you there,
Hi,
Sujai?
Chris.
Yep.
Yes,
Hi.
I'm here. Yes.
Okay, so I'm going
No
to
worries.
validate it against a particular class, and I'm going to see what my output is. And it doesn't like that, so let's, okay. All right, so what it's telling me is that my person data isn't valid according to my enumeration that I put in, because as you remember, my person data, I added a lowercase alive here, and what it wants is me to conform to that enumeration. So I need to change these to capital alives. And I'm going to run that validation again. Hopefully it'll start putting stuff out here. Right. And it's going to tell me a few other things too, which is wonderful. It's going to tell me that I have some unrecognized prefixes. Those are just warnings. And then down here in the bottom, it's going to tell me that because I copied over that schema of where we would have gotten to if we had more time, I actually constrained my email address down to this pattern. So if I look back in my schema just really quickly, I can see that email address here, primary email, has a pattern. This is another LinkML construct where I've constrained down the email address to what I think a person's email address should look like. And Fred Boggs needs an @ So let's do that one more time. And we should get, we've validated. So we have no errors. Our schema is valid, our test data is valid, and we need to address these warnings, but not right now. So again, if you want to get the entirety of the model that I have, sorry, go ahead.
Sorry, just a quick question here. Yeah.
The validator, if it finds an error, it stops at that one and doesn't show you other ones?
That is correct. Yeah, that's something we're addressing. Yeah, that's, yeah. That's okay.
Yeah, you can just, I probably am muted again.
No, you're good. You're good.
Okay, good. Okay. So if you want to catch up with us, go ahead and check out the branch step 6 enumerations, and you'll get the schema that you see on my screen. And that's sort of the very basic level of LinkML model components. One last thing I want to show you before moving on to the rest of our demo is this handy link. I showed it at the first slide. This is the documentation for the entirety of the LinkML meta model. And it's really nice. Chris has already done a really excellent job of documenting what we have in terms of, slots and how you can constrain them and how to see examples further on in this demo. So I really encourage you to go to that documentation and just look through the model, and you'll see that there's a lot of other full features that we weren't able to get to today. And I think the next person up is Patrick. And I just wanted to point out that Anita in the chat already won all the internet points for this demo, because she already found while I was typing the purposeful typos that I put in our schema so that LinkML's linter that Patrick is going to show us can find them. But just pretend you didn't see me make any mistakes whatsoever. And Patrick, take it away.
Yeah, that's right. Thank you. You made no mistakes at all. You did a great job. Okay, so right, I'm going to talk about the LinkML linter. The linter it's a tool to help you enforce best practices in your schema and to identify error-prone patterns or likely mistakes. To put it another way, it helps you find things that aren't necessarily wrong, but they could be better. And depending on your level of technical,
we lost you.
Hey, Sierra, it's not
okay. You're back.
It's not just you, Sierra. So depending on your level of technical expertise, you may have encountered similar tools before. Many programming and markup languages have linters or similar tools. So, and the LinkML linter kind of borrows ideas from these tools. So this slide just kind of gives you an overview, but I'm gonna pop into my IDE here. And I'm just going to run through this. We're kind of running short on time, so I'm going to go through this like really fast. So if you don't follow along with me and just want to watch, that's like fine too. So the basics of this command, so it's LinkML lint, and then you point it at the schema or.
Does it help if I talk?
You're back.
Okay. So yeah, so you can, it's LinkML-lint, and you point it at a schema, or this can also be a directory of schemas, and it'll check all of the schemas in the directory sort of recursively. And we give this a second to run. And so what this is pointing out to us, so first of all, it's going to list like the file that it's, where it found issues. And then it lists out different issues that it identified. So let's just decode like one of these here. So first it's saying as a warning, And then the next part is like details about what it found. So it's saying the class definition person does not have the recommended slot description.
Patrick, could you maybe zoom in a little bit? Make the font larger.
Yes.
Mhm.
How's that? Is that good enough?
Is that good? Yes. That's
Okay. And so, okay, so yeah, so this is details about the issue it found. And then if you need more information, the thing in parentheses here is the name of the rule. So the LinkML linter is based on like a series of rules. This is the name of the rule that's like failing. So it's the recommended rule. So if I pop back over to documentation, so this is the documentation page for the linter. There's a rules section, and I can find in here a rule named recommended. And so this will give you more information about what the rule is checking for. In this case, it's pretty clear. Like it's saying like it doesn't have a description, and it should. And you can see that like a number of things.
Sorry, Sujan.
Hi, can you, are you back?
No, that
Yeah.
didn't work that time.
Hello, hello.
Hello?
Can you hear me?
Hello?
Can you hear
No,
me?
we're not
Can you
getting
hear
any
me?
audio from anyone.
Oh,
No. Still no?
Oh no.
Chris, can you hear me?
Like this.
Are you here there?
You can hear us?
Yeah,
Yes.
we can hear you.
Oh, you're back. Okay.
Okay, great.
Okay.
It might be that we're
Um,
double muted. So if Oliver's there, have you double muted the Zoom by any chance? Meaning that you've set everyone to mute on Zoom. That might be something to check into while Patrick's talking.
Anyway, carry on. We're good just now.
Okay. Okay. So you can see there's a bunch of things here that it's flagging as not having descriptions. Again, that's like a best practice sort of thing. You know, you should put descriptions on things. So real fast, I'm going to try to fix these by adding a description to, so my person class is up here, give that a description. And animal, give that's a description. What else is missing one? Animal collection, there it is. And then enums. So the enums down at the bottom here, they also should have subscriptions. So let's find those. Okay. Person status. Let's give that a description.
I don't know if you fix this, Oliver. Sorry. It's
Can you still not hear us?
Hello? Hello?
Still
Hello?
talking.
Uh,
You're a co-host now, Patrick.
oh, how exciting.
No volume.
No volume still.
It's odd because it never cuts out for remote participants.
Yeah.
Now we can't hear you either, Chris.
Yeah, now we got nothing. Well, I can hear Sierra.
Chris is muted though. Mark's computer's muted.
Can you hear? Yes, thumbs up. Okay, I'm gonna keep talking then. I gave all this, I gave a bunch of things descriptions. I ran the linter again, and you can see it's giving me fewer issues. So the ones that were tagged with the recommended rule are no longer there. It looks like I still have some issues about standard naming. So in this case, it says class name. Class has name person underscore collection. And again, if I'm confused about what it's asking me to do, I just go to the documentation, find the standard naming rule here. It's saying it wants camel case for classes, snake case for slots. So you can see it's that underscore that's causing confusion here. So let me find person. So that should be named person collection with no underscore. And then, as Anita already pointed out, birth date with a space. That should be an underscore there. Again, there's nothing. So this is spaces are allowed, right, in names. It's just a best practice sort of thing. That's why, like, Sierra's examples, they worked, right? They worked, but this is just, you know, enforcing best practices. And when you work on larger schemas and you work on them with like a lot of different people, enforcing those best practices becomes really important. So I am down to just 3 warnings now. And so, okay, so fixing issues is obviously one way to address a failing rule. Another option is to actually change the linter's configuration. So we've never really told the linter like what rules we want to check our schema with. So it tries to use a reasonable baseline set, but that may not be right for
Oh, they
every
can't hear me.
project.
Sorry. Okay.
Oh,
We've lost you for a bit. So
Can you hear us?
could you try, Sujai?
Okay.
Maybe
Yeah,
your trick
can you
here?
hear me? Can you hear me? Chris?
No,
Can you hear me?
no, we've lost you altogether now.
oh boy.
Okay,
Oh.
gone
damn.
all together.
Wheel?
Maybe just should we do the transition now? Yeah. Okay, so just to avoid this issue, we're gonna transition to Mark. Maybe you just kind of like sort of like verbally wrap up this section and do the documentation and the schema sheet section.
Yeah.
Okay, so provided you can all hear us in Zoom land, I think that makes sense. So let's do that. Mhm.
Patrick, Sujai, Sierra, thank you so much for the presentation so far. And I'm going to present on some material that I contributed to almost none. So the linter was almost all Patrick's work, and the documentation generator. A lot of the most recent commits have come from Sujai. So let's go back to the slides for a second. We are up to the linter. Patrick has shown the kind of warnings you get from the linter. The linter command is very easy to write. There's also a makefile rule. If you just type in make linkml-lint, that'll do the same thing. And he's right, run linkml linter often and look at the output, and like you said, check the documentation for the rules. That'll let you know why something was considered not a preferred way of expressing something in linkml. So now we'll go into the documentation generation. We're going to move at a quick pace, but you will be able to check out a already built version of this by going to the you would do git fetch and then git checkout. Remember what the yeah. So
Sharing the screen.
I am not sure.
On Zoom.
On Zoom. Thank you. Sorry about that. I'm also not really doing full screen, am I? Okay, so yeah, you can use git checkout step _8 _ documentation or docs. Somebody can confirm that in the Zoom chat. That would be great. So the great things about linkml documentation is that you write a schema and then you write one command and it generates markdown pages that you could look at with a markdown generator, but then it can be deployed as HTML pages locally that you can look at before you send anything to GitHub, and it can be sent to GitHub at the point which you're ready to make it a public artifact for people to learn about your schema. So one very quick way to do this would be to type in at a command prompt at the root of your GitHub repo, make space test doc. And that'll do the markdown generation part and the starting up a web server, a kind of ephemeral temporary web server on your computer. So try that. If you have any schema, as long as it compiles correctly, whatever you have, make space test doc, and on the command line, you will be given an address to where you can find your linkml schema web pages. On almost everyone's computer, I expect it to be HTTP or HTTPS the local host address, which is 127.0.0.1, port 8000, and then the name of the schema that we're working on. Has anyone been able to run the make test doc command? And are you able to open the web page? Okay. Could you see how he's coming along? So we have one person who completed the make test doc command, but hasn't seen their web pages yet. I'll just show it myself. So I'm not exactly sure what's been going on here recently, but we're at the root level of the LinkML tutorial repo. I'm going to type in make test doc. Maybe it's test doc without a hyphen. And this is pretty quick, but as your schema grows, it will get slower. Okay, and so at this point, if you get an info statement that says your documentation is being served on 127.0.0.1, et cetera, you can either copy and paste that into a browser, or depending on your shell, you can just click on it and you get this documentation. Over here on the right, we have an index. Maybe I shouldn't use the word index because index is in the upper left, but the table of contents has quick links to the main elements that we've talked about today. We have classes. So here's a list of all the classes that comes in my version of the model. I think I've forked off a little bit from what Sierra was talking about, but we do have a person class. And when you go to a person class, one of the things it shows you is the slots. And if you see a slot that you're interested in, you can click on that and get more information. And so things you might see here would be something like, if it's a multi-valued slot, or if it's a required slot, that will appear here. So the classes and slots, and even the enumerations, if we go back to the, let's go back to the home page here with this person reading a book icon. If you go to the enumerations, that will also tell you what kind of enumerations you have, and the schema in the version that I've frozen it on doesn't have any enumerations. But all these top level, we've talked about classes, slots, enumerations. We only talked about types in passing. I don't think we talked about subsets at all. And then the next thing you can do after you've viewed it locally is you can do something like Control-C to get out of that, and you can type in make deploy. And if you have entered a real GitHub org during your cookie cutter setup, and you've entered in the name of a repo, make deploy should rebuild your schema, rebuild the documentation. These are called, we can call these generation steps. So taking your schema and generating it to Excel files or JSON schema, JSON link data, those are all generations. Making the documentation is also a generation step. So we have made various schema artifacts, including the documentation, and you'll see down here at the bottom that I got a message that says your documentation should shortly be available at a GitHub Pages link. If you try this yourself, you may not, I think this is loaded. Yes, this is. So I don't know if you noticed this before, but the last time I showed this, my web content, the address for my web content was 127 ... etc. My local host, it was running off of this computer. But now any of you could type in linkml.io/linkml-tutorial, and you'll get the same documentation page.
It won't quite be that URL.
It won't be quite that
Your
URL.
personal GitHub,
Yeah.
GitHub.io/
Yeah. Good clarification. Thank you. Okay, so I would love to spend more time on that, but the take-home points are that just like you can convert other computable artifacts, you can generate documentation pages, you can interact with them locally, and you can post them to GitHub Pages for the public to see. You don't have to create any site of your own with GoDaddy or something like that. Those of you, Patrick, et cetera, or Sujai, if you have something that you want to add, please add it to the Zoom chat, and I'll try to bring it up. Okay, anything else? Oh yeah, and Sujai has this great visual that kind of covers what we just did. And it adds one thing I'm going to say super briefly, which is we take the LinkML YAML version of your schema. There's a command called a makefile rule called makeGenDoc, which uses the GenDoc command line underneath that. We can serve it. So we're showing both in dark peach, we're showing makefile rules that you already have that can do this stuff. Some of this pink box, this blue box here, GenDoc is a command line tool. And you can see some of the kinds of artifacts that are created. And down here, this is the secret sauce that I'm only going to say briefly, which is you can customize your own documentation pages. There are templates written in the Jinja 2 language. You know, you wouldn't expect to make your own Jinja templates today without reading some documentation, but we don't expect you to just like our style. So that's something you can add in the future. And in addition to changing the Jinja, you can also choose different themes. So by choosing a theme and making changes to the Jinja template, you can really make this look like your own project and not worry about making it look like it's something generic. You get all the benefits of the generic underpinnings, but you can really make it your own. Any questions? Okay.
Maybe just to emphasize as well that you don't actually have to run a lot of these things on the command line yourself. You just kind of like push these out to GitHub. GitHub takes care of just deploying all of the documentation features for you. So it really is a one-stop shop.
Yeah, I'm going to resist the temptation to show that right now. These would be considered GitHub actions. Okay. Schema sheets, also something that I didn't write, but I use quite a bit. I'm going to take the suggestion here. I'm going to check out the schema sheets branch. So I know this is probably really small font. I don't know how to magnify this, but that doesn't work in yeah. And I hope somebody's looking at the Zoom chat. I'm going to use PyCharm's trick here because I can't remember the name of the right branch. I'm clicking the lower right, which lists branches, and I'll just type in schema sheets. Schema sheets is step_9_ schema sheets. So in addition to
just do schema sheets if you can hear me.
Force checkout. In addition, you could type in git checkout step. Is it step 9? You have to spell it, right? You have to spell everything, right? Okay, I'm sorry. I'm in the interest of time, I'm not going to fix my typing errors. Okay. I have checked out the schema sheets branch, and we're going to do something now that may not be considered a best practice for if you're a software developer. You usually like to really trust, Git. So you could check in what you've done and you can make any changes, overwrite files, delete them, and you wouldn't worry about it. But in this case, I recommend making a copy of your source LinkML tutorial schema, LinkML tutorial.yaml, and just copying it to a backup file, because you might want to do a little bit of, or you can just follow along with me. I'm going to do that. So I'm going to take this command. Sorry. I think we're all feeling rushed and getting nervous. Okay, I'm just going to type that in longhand. So we're going to do copy. I don't need to make that. Okay, thank you. Okay. So you'll have to trust me. So having said that, let's go back and just understand the reason we're talking about schema sheets. Everything we've done so far to make a schema has been a matter of editing YAML files. White space is sensitive. You have to know the right kinds of names of LinkML elements, and that's the most powerful way of doing it. But if you want to have a collaborative environment where anybody can contribute to a LinkML schema and not need to run commands, except for one person, you could have a big team. You might want to have some sort of policies about, people. There is a mechanism within Google Sheets to, roll back and look at version changes. You might want to supplement that with some policies, but you can have collaborators editing information about a schema just in a spreadsheet, and only one person on the team would need to know how to compile that down to YAML. This is recommended as a one-way operation. If you like schema sheets, you don't want to edit YAML, you would compose in the sheet and then compile to YAML and not try to do a round trip unless you want to be bold and use some experimental features. So I'm going to focus here on this sheet. This is a screenshot of a Google Sheet that we'll be able to share with you. And this very first row can be any column heading that's meaningful in your scientific discipline. If you have a spreadsheet that already has this kind of format that talks about classes or kinds of records and attributes, you may very well be able to keep this first header, and you need to add some extra header rows, which we call column specifications. And the column specifications either mention a kind of LinkML element, like a class is a LinkML element from the LinkML meta modeling language. A slot is a kind of element. But then you'll also see that identifier, that's something that Sierra talked about. That's an attribute of a slot. So here on this first row, we're making a declaration about a slot. All we're saying is that this model should have identifier slots, ID slots called ID. They should have the attribute of being identifiers. We're just going to confirm that it's a string range, add a description, et cetera, et cetera. This is all you need to do to define a slot. Then down a couple, there's a definition for the person class. How do I know? It's because the word person is under the class row, and it uses some schema sheet shortcuts to say, we're not going to take a stand on whether that's an identifier or not. They're not really applicable for a class. But we are going to give a description, et cetera, et cetera. And then one row below that, we associate the ID slot with the person class. And any other columns we fill out there will be customizations of the ID class customizations of the ID slot just for the person class. We call that slot usage within a class. You could have a customized description or maybe a different validation pattern. So we have a combination of all those things here. We have slot definition rows, class definition rows, slot association rows, person with ID, person with age. There's even shortcuts to keep the sheets nice and compact. You can say both person and organization use the name field. So as long as you stick to this standard, the second and subsequent rows have to have a greater than symbol. The things that you can mention here have to be either a legitimate LinkML attribute, like a name of an element, like a slot or a class, or an attribute of that element, or a shortcut. We have a link in here. The schema sheets data model. This is LinkML IO schema sheets data model shortcuts has an explanation of what kind of headers you might see. Let's go back to, excuse me. Okay, so that's how you compose the sheet. And then all you have to do to get something like this to work is it's easiest if you use this templated rule. I'm not going to explain it right now, but this would be a way that you could put this templated command in your project make file and take advantage of the fact that some of this stuff is already defined in your about YAML file. You could just run a LinkML schema sheets command directly. If there's time, I'll talk about that briefly. So if we were going to do this as an activity together, I suggested copying a file. We're going to skip that. Since I checked out the step 9 schema sheets GitHub branch, I already have this in my project make file. We have a schema sheet. This didn't turn into a link for some reason, but bit.ly/sheets-t files. You could make a copy of that and start experimenting with schema sheets. I'm going to do that myself. I think I have some schema sheets ready to show. Let's look for schema sheets test file. So here's my copy of this. I've added some extra features here. I've added a new slot called person-handedness. We haven't talked about that before. I've made person-handedness and I've put a pattern on it. So what I've done here compared to things we've looked at before is I've added a row. The row does two things at the same time. It defines the handedness slot. It's pretty sparse. I don't have a description or anything like that, but it says that handedness is a slot. All values in data that are bound by the handedness slot must follow this regular expression pattern. I'm using the pipe characters to say there's 3 legal values. That's kind of a quick and dirty cheating way of making an enumeration. And then because the word person is in the class, like I said before, it's not just a definition, but it's also an association. So let's look at my project make file. Okay, that didn't make it into the branch, unfortunately. I can do this pretty quickly. Okay, so we're gonna copy this. I'm sorry, this may not have made it into the branch. I'll fix that at lunchtime. There is one catch. If you try to follow along with me and copy this little bit of text, these 3 lines into your project make file, you will have to add a tab character. For some reason, it doesn't copy over when you copy from the Google slide. So if you're following along with me, make sure on the 3rd line, you enter a tab character. And this rule that we're making under the covers uses the sheets2 LinkML command. So if you want to do this manually and learn about all the options, you could do something like you could type in poetry run sheets2 LinkML -- help. So now that we have this rule and I have saved it, I could do something really radical, like here, look at my schema folder. I already made this backup file, but there's no non-backup schema in here. In fact, really to drive the point home, I'm going to even delete the backup. This is where the schema should be. Source, LinkML tutorial, schema. We have a rule here that runs schema sheet. It's going to look up the sheet ID and some other variables from the about YAML file. You don't have to do it that way. You can hard code all this stuff, but this is some of the conveniences you get from this cookie cutter template that we started with the cruft command. So here I can type in make, what's the name of the rule? It's probably compile, make compile sheets manually. If you try to run this by clicking it in your IDE, if your IDE supports make files, it probably won't work because this is actually a module that gets imported somewhere else. So the best way to try this yourself is make compile sheets manually. And it is currently, it's using a software library from James Overton called COGS to download the content of that Google Sheet locally. And
Actually use COGS.
this step doesn't use COGS.
No, but you can.
Okay.
This is a great tool for syncing between your Google Sheets.
Okay.
And your file.
Thank you for clarifying. Okay, so now in our schema directory, showing up. Huh. There it is. Looks like I added an extension called schema here. In fact, I can fix that. Let's go here. I probably shouldn't fiddle with that now. Okay, the point is that from a Google Sheet, I have regenerated the schema. Everything you see here written in YAML, nobody ever typed this in. We didn't clone it from the repo. I didn't type it while you weren't looking. It was generated from the Google Sheet. And I'm going to LinkML tutorial source, LinkML tutorial. I am going to copy this up into this schema directory. And we can continue with various testing steps. So we can say make test. We haven't done this manually yet, but you could do make test Python, which looks at your schema, generates a Python class from it, Python data classes file, and then validates it against some data. And I think this will probably fail, and this actually passed. You probably haven't seen this before, but here in the test directory, there's some test data. Sierra was showing how to do roughly the same thing with a LinkML validate command. This is another way of validating your data, which is to say, I want to write a Python program, and I want to import a certain class, and then I'm going to load in some data from a YAML file. We're going to loop over all the example files and try to instantiate the data as the class that we were interested in. I think I'm going to stop here. I think the take-home message that I want to share with you is that we have good documentation for schema sheets. So Schema Sheets has a GitHub repo. Like most of our GitHub repos, they have a link to their documentation in the upper right About section. If you scroll through here, you'll see these example Google Sheets. This is what we were just using. And you can, I don't know, if let's fix one thing and then I'll hand it back off to Chris for wrap up. And I guess if there's questions, we can field a couple questions. So if you were paying attention when I did this compilation step, which I abstracted as make compile sheets manually, we got a warning. Actually, the warning is left up here in my previous shell that some prefixes hadn't been defined. And if we go up here, you'll see that, let's look at, there's several tabs here. Schema sheets can be broken into separate tabs or separate TSV files, if you're using TSV files, that are focused on a specific kind of content. Like, it probably wouldn't make much sense to put information about enumerations and classes and slots all into the same sheet. You technically can do it, but as your schema grows, you're going to want to have some separation of concerns. So we have a person info tab, some enumerations, 2 enumerations, each of which have a couple of permissible values. We have a prefixes tab. Well, we just got an error about prefixes being undefined. So let's go to our about YAML here. And you can see, you can tell the schema sheet subsystem which tabs to include. And we're just including person info and enums. And we got some warnings here that the prefixes weren't defined. So we'll just add prefixes. And I'm going to add the schema tab also and save this and rerun the sheet compilation. And now we won't get those warnings. So this is a typical workflow that you would follow, which is you add something to the sheet and then you compile it. You may get warnings, you may get even outright errors. And then the next step after that, actually in any style of LinkML development, is to then validate some data. So you should always be in this habit of working on your schema, but also having some sample data that you can validate against. And you should experiment with your data. You can add slots that aren't defined. You can add values that you think are illegal. And you should be able to predict when will the linkml-validate command fail because the schema isn't in agreement with the data. And what can you do to fix it, either by changing the data or the schema. I can talk about this more during lunch breaks. Are there any questions specifically about schema sheets? Okay, well, thank you yes.
Sorry.
Yeah. If you, yes, thank you. The question was how hard would it be to apply what we've already seen with the existing TSV? And as long as your TSV is an expression of a model and not bare data, all you have to do is add one or more header rows below your existing header. You keep your existing header. So if you had a sheet that started with this row record and then resumed at row 4, this is the way you're expressing your model, you just have to insert rows. And I'm glad you asked that, because if you have a column and you're not sure how to implement that within schema sheets, I'll do this right now. B2, we're currently saying this column expresses slots, but you could start taking an existing CSV or TSV that tries to express a model, and you could make as many of those columns as you want, ignore columns, and start with something that you are pretty sure will compile. Like if you have a name of classes, you can make every other column an ignore and see that that compiles down. This isn't how you would take a sheet of data and integrate it into the LinkML system. We have tools for that today that we had to skip, but I'm glad to meet with people and show both paths, taking a sheet of data and inferring a schema from that, or a sheet expressing a model in some other system and adding minimal additional rows to make it a schema sheet. Good question.
All right, thank you, Mark. So we'll just open up now for just like any general questions. But also, I just want to emphasize for those of you in the room, Mark and I, we're going to be here all ICBO. I'm actually going to be here US2TS as well. Please just grab us at any point if you want us to sit down with your laptop and kind of work through anything. And for folks here and on Zoom as well, you know, we really welcome any issues on our GitHub issue tracker about anything at all, whether it's getting set up, whether it's kind of conceptual questions. So, but let's just see if there's first in the room, if there's any sort of like general questions anyone has, or thoughts, impressions, comments. Yes, over there.
As schemas get bigger, you would, I think most people would want to break up into multiple files.
Yes.
And so would you use the imports to handle that, or how would you break up the one schema into multiple files?
Yeah, the question is about breaking a schema into multiple files. So yes, that's exactly what the imports directive that you see at the start so far in the examples you've seen, you've only seen one import to LinkML types. That's like to the built-in types. But we definitely encourage you to kind of modularize your schema. There's different design patterns for how you do that. You know, you may have either enumerations in one file, or you may have one file per enumeration. It's up to you how to do that. But yes, and typically you would have them just as different files on the file system, and then you would import them all. You can have them, it'd be even more modular and have one group have their own repo with their schema, which you import, over the network that way. But, it's, for most people, it's going to be, just splitting their schema over multiple files in their own file system. And of course, tracking all of those in GitHub, makes most sense.
How does,
One more, yeah.
I'm not trying to compare apples to oranges, but how does any of this differ from the selfie plugin?
I'm trying to remember exactly what the selfie plugin does, but I believe that's for, yeah. I might punt it. Jim, do you? Yeah, so the question is about how this differs from the selfie plugin. And I think the comparison there, as Jim is saying, is more to robot template, which again, you can hear about tomorrow, which is more about, ways of building an ontology from templates. And, it's a very kind of common idea, this kind of like, giving kind of curators a kind of template from which they can build schemas, ontologies, and so on. So robot template is the analogous tool that we use for building ontologies, whereas this is more for building schemas. Yes. Mhm. Do we have any, if there's any questions on Zoom, if you want to either unmute if that works, or put something in chat. We've got another one in the room. Question? Go ahead.
My questions are always roundabout, so sorry, but it's kind of a people question.
Yeah.
Have you done this with somebody, and with some group trying to meet their schema goal, and what predicted success? So if you got to collaborate in these spreadsheets.
Yep. Mm-hmm. And so you're talking about the schema sheets per se, or the whole yeah.
Theoretically, this is your broadly accessible.
Yes.
Right?
Yep. Mm-hmm.
So is there something that makes it work out better talking to lay people using this?
Yeah, so the question for those of you on Zoom is just kind of like what are some predictors of success for using the schema sheet system? What kind of things make it easy for other people? And yeah, I mean, we've used this, I will say most of the projects we have, people are currently using the direct YAML editing, but there's a few where we've tried to bring in kind of curators who are not technical. So we did this for kind of like a cancer data harmonization problem. And I think, Mark, you're probably the best person to answer this from the perspective of what we've been doing with metagenomics standardization. So do you have any comments on that? Good metrics for success, or do you want to speak here? So
I'll give you 1 second. The MixS standard for communicating a minimal standard about any sequencing project, like a metagenome project or a cultured organism genome, that has been expressed as Excel sheets in a proprietary format for a couple of years now, and that is currently being migrated to schema sheets after having gone down the path that Chris recommended, which is just write a LinkML model. In fact, Chris wrote a custom converter for converting from these Google Sheets to the LinkML standard. And it was a good quick win, but for allowing people to collaborate on this, the GSC MixS standard, I think 6.2 is going to be natively schema sheets.
While you're there, can you bring back the slides up in your many tabs?
Here.
Okay. All right, maybe time for one more question before we wrap up, Jim? Oh, okay. Let's see.
Chris, can you hear us at all?
Okay, so the question from Matt. Oh, hi, Matt. So in terms of modeling features, can you provide some quick comments about what the overlap with Shackle is? So that's a very good question. So there is a lot of overlap with Shackle. So Shackle is a shape language for RDF. So there's actually two main shape languages, Shackle and Shex, and they both do similar things. And the main end goal here is to be able to validate an RDF document according to a schema. So there's a lot of similar ideas here, but one of the main differences is LinkML is designed for use either within or outside of the whole RDF ecosystem. And you can in fact take a LinkML schema and convert it to Shackle if you like. There are maybe some features that Shackle has that are not in LinkML yet, and there's maybe some things in LinkML that are easier to model in some ways. So yeah, it's a good question. There's some more info on the LinkML FAQ about that. Okay, so I'll just leave with a kind of couple of links up here. So again, a lot of what you've seen today can be found on our website here. There's a link to an older tutorial there. There's an FAQ, instructions for getting started. Again, here's the link for our GitHub repo. So really welcome any questions there. And indeed, if you have anything you want to contribute as well, we especially love pull requests. As I said, we're a very open project. We're currently figuring out the best way to kind of connect to a broader community. We have a group that meets on a kind of like a project specific Slack. We're either going to start up a kind of more community channel on the existing Obo Slack, or maybe we'll use Discord or Zulip. So if anyone's got any preferences, please let us know and we'll let you all know about that. And just with that, I really just want to thank all of the people, many people who have contributed to this, especially to Sierra, Sujai, Mark and Patrick, who did a huge amount for this tutorial today, Harald Solbrig, who built a lot of this this framework, and a whole bunch of other contributors. And your name and little GitHub image could be here too as well after this. So we welcome all contributions. And with that, we'll close out. Those of us in the room can maybe join the disco that's happening next door, or I don't know what's happening there. So sorry about the background noise. And thank you all, everyone on Zoom. I hope that works out well for you as well. So thanks again, everyone here.